Hello everyone, welcome to the SP Learning Labs Java programming course. In this course, we are going to learn Java in very simple and practical way. We are not just learning code, we are learning how developers think. If you are a beginner, don't worry at all. Think of this like learning a new language. First, we learn small things, then slowly we build bigger programs. So just relax, follow along, and let's start our Java journey. What is Java? Before writing any code, let's understand one simple question. What is Java? Java is a programming language used to build websites, mobile apps, business applications. It is high level language which means it is easy for humans to read and write. Java was created in 1995 by James Gosling at Sun Microsystems. The first version came in 1996. Now Java is maintained by Oracle team. Now the most important concept, write once, run anywhere. Vora. This means you write code one time and it works on Windows, Linux, Mac. No changes needed. How is this possible? Because of JVM, Java Virtual Machine. JVM acts like middleware between your code and the system. It takes your Java program and runs it on any operating system. Don't worry if this sounds confusing right now. We will learn this in detail in the coming videos. For now, just remember one thing. JVM helps Java run anywhere. Evolution of Java. Java has improved a lot over time. Java Standard Edition used for learning and basic applications. Java Enterprise Edition used for large company applications. Today it is called Jakarta EE. Modern Java keeps getting updated regularly. Every new version is faster, more secure, powerful. That's why in real projects we usually use the latest versions of Java. Why Java is important? Why do companies still use Java? Because it is secure, reliable, platform independent, enterprise ready. That's why Java is used everywhere. Now we will run our first Java program using the command line. Let's create and execute a simple program called Hello World. You all have a notepad in your system. So I am using notepad to write the program. First we create a class. My class name is Hello World. Here we are using curly braces. These define the block of the class. The opening and closing curly braces shows where the class starts and ends. Now inside this we write the main method, which is the starting point of the program. Here also we are using curly braces. These braces define where the method starts and where the method ends. You can see here string array args. These are the arguments passed to the main method. Don't worry about this part now. Just understand that this is required to run the program. Now inside this method I will write system.out.println. Here we are using system.out.println to print the text. Whatever we write inside these codes will be printed. So this will print hello world. Here we are ending this statement with semicolon. In Java, most statements ends with semicolon. Now I save this file. The file name must be same as the class name. So I save it as hello world with .java extension. After saving the file, now we will go to the command prompt to run our first Java program. You can see here command prompt is open. Now we need to go to the directory where our file got saved. Here, now I will use the Java commands. Since Java is already installed in my system, this will work. Here, I am using javac. This command will compile .java files into .class files. You can see now .java file is compiled. You can check here in desktop folder. Here you can see hello world.class file is created. Now we will run our hello world program. Now when I press enter, now you can see the output hello world. Boom, you just ran your first Java program. First we compile, then we run. Don't worry if this feels confusing right now. We just saw class, main method, string args, system.out.println. We will learn everything step by step in coming videos. Java is used in many real world applications. Banking systems, e-commerce platforms, Android apps, cloud and microservices, big data tools. If the system is big and important, Java is usually there. Java vs other languages. Let's compare quickly. Java vs Python. Java is fast and scalable. Python is easy to learn. Java vs C++. Java is platform independent. C++ is more memory control. Java vs JavaScript. Java is backend systems. JavaScript is front-end UI related. Career opportunities. If you learn Java, you can become backend developer, full stack developer, Android developer, enterprise developer, cloud engineer, software architect. Java developers are always in demand. So today we learn what is JVM, what is Java, what is Aura, Java evolution, why Java is important, how Java program runs, real world usage, career options. In the next video, we will install Java step by step and set up everything properly. If you found this helpful, like, share, subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to install Java, set up environment variables, install Eclipse and run our first Java program. Let's get started. Now let's install Java in our system. Before that, let's check if Java is already installed. Open command prompt and type java-version. If you see a version, Java is already installed. If you see an error, Java is not installed or not configured properly. Now let's install Java. Open your browser and type download JDK. Here you can see official Oracle website. Click on this. You can see here different versions Java 26, 25, 21 and also earlier versions available now. Here you can see Java 26 is the latest release of the Java standard platform and Java 25 is the latest long-term support release and also same 21 is the previous long-term support. Java 26 is the newest version, but I am choosing 25 because it is stable and better for learning. And based on your operating system, you need to download the correct file. Since I am using Windows, I will download the Windows installer. Now you can see here 64 installer with .exe file. Now when I click on this, it will start downloading. Now you can see downloader is completed. Now I will go to the folder and click on this. Now you can see here preparing to install and you can see here welcome to the installation. We click on next. Now here you can see the where it is going to install, it will show the path. Keep those default settings and we click next. Now you can see Java is successfully installed in our system. The installation process is very simple. Now click close. Now again we go to the command prompt and type java-version. We need to close this and open again. Java-version. Now you can see the version we have installed, Java version 25. In newer Java versions, the installer sometimes set the path automatically. So Java commands like Java and Javac start working directly. But this may not happen in all systems. So to be safe, we will set environment variables manually. Now let's set environment variables. Go to search and type environment variables. Here you can see edit system environment variables. Click on that. Now here we can see system properties, edit environment variables and click on environment variables. Here we can see fields. Now I will click on new and set a variable name as Java home. And pass the variable value as we can directly browse the directory. During the installation, we see that it is installed in C. We go to the C and go to the program files and find Java. Here you can see JDK25. Select this and click OK. Now we have given the path where Java is installed and click OK. Java home tells the system where Java is installed. And after this, now we need to update our path. Click on the path and click new and browse to the Java bin folder. Select bin folder Path allows us to run the Java commands from anywhere. Remember, in the previous video, we ran Java commands from the desktop folder and it worked without any issue. This is because path is set correctly. Once this is done, click OK and save everything. Now, once again we type java-version. You can see the Java version 25. Even if it worked automatically before, now we have properly configured it. So it will work correctly in any system. Now we will install Eclipse IDE in our system. Eclipse is an IDE. It helps us write, run and manage code easily. Compared to command line, Eclipse makes our work easier and faster. Now open the browser and type download Eclipse. Here you can see official Eclipse website. Click on the first link and here you can see about Eclipse. And click on the download 2026-03. Here you can see on top right download option. Click on this. Now when you go down, here you can see again download option. Click on this and select 8664-bit. Now again here you can see download option. Click on this. Now Eclipse IDE will get started downloading. Now Eclipse download is complete. Now we'll click on the installer. Here you can see Eclipse installer is opening. Here you can see Eclipse installer is open and here you can see many options. Eclipse IDE for Java developers and like this many IDEs are there. We will select the Eclipse IDE for Java developers and click. Here you can see options JRE21. Since we have installed JDK25, we will select JRE25. And here you can also see create start menu entry, create desktop shortcut. It will create the shortcut for Eclipse IDE in our desktop and select install. Here we'll accept this and it will start installing Eclipse IDE. Now Eclipse is completely successfully installed. Now here you can see the launch button. Now we will click on this. It will open the Eclipse IDE. Now here you can see the workspace. Select a directory as workspace. Workspace is just a folder where all your projects are stored. And click on launch. Now you can see Eclipse IDE is open and we can write our Java programs. Click on this. Now here you can see many options. Create a Java project, create a Maven project, create a project, import projects. We'll click on create a Java project. I will keep the project name as beginners. Here you can see the use default location. We will keep this as same and click finish. Now here you can see our Java project has been created. This is our project structure. Here you can see JRE system library src folder. This JRE system library contains the Java core libraries. This is where we write our code. All our programs will be created here. Now, when I click on this, here you can see new option and here you can see the class. Here we will create our first class, Hello World. Now here you can see the option public static void main method. This tells us this class should contain the main method. And we click on finish. Now here you can see the beginners package. Inside this package we are having helloworld.java file. We will discuss this package related in the coming videos. Now here you can see our class Hello World. If you remember in the previous video, we have created everything in Notepad. We wrote the class, curly braces, main method, step by step. But here we can simply select the main method and Eclipse automatically generates the code for us. This is how IDE simplifies our work. Now here inside this main method, we will write system.out.println. Here you can see in Eclipse IDE, it will give the auto suggestions. And inside these codes, whatever we write, it will get printed when we run our Hello World program. Now our Hello World is ready and we'll run our Hello World program. In the previous video, we used command prompt to compile our Java program. We used commands like javac and java. But here, Eclipse does that automatically for us. We can simply click the run button and it will run the Java program. Here, I will click the right click. You can see the many options. Here you can see run as option and click the Java application. Now our program will get executed and here in the console you can see the hello world output. So how easy it is. Just one click the program runs. Behind the scenes the same process is happening. Eclipse is compiling the program and then running it. Earlier we did this manually using javac and java commands, but here the IDE is doing for us automatically. One small thing to understand here. In Eclipse, Java is already configured properly. So even if Java is not fully set in your system, Eclipse can still compile and run your program. But when you use command prompt, Java must be installed and configured properly. That's why we set Java home and path earlier. So both ways work. But Eclipse makes it easier by handling things for us. Great! Now your Java setup is complete. Now we will discuss some of the common mistakes. Installing JRE instead of JDK. Remember, JDK is required for development. Not setting Java home. Because of this, the system may not know where Java is installed and not updating the path. Then Java commands like Java, javac will not work in command prompt. So these are the common mistakes you should avoid. So today we learned how to install Java, how to set environment variables, how to install Eclipse, how to create and run a Java program. In the next video, we will understand JVM, JRA and JDK in detail. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, Welcome back to the SP Learning Labs Java programming course. In today's video, we will learn what is JVM, what is JRA, what is JDK, how they work together. Let's get started. In the last video, we installed Java and Eclipse. We created a project, created a class, and wrote a simple program. Then we clicked run and saw the output hello world. Now the question is, what happened when we click run? How did this program execute? Let's understand step by step. In Eclipse, everything looks simple. Write code, click run, output comes. But internally, many things are happening. Even though we don't have commands like Java say, Eclipse is compiling the code in the background. Java uses three main components: JVM, JRE, JDK. Now let's understand each one clearly. JVM, Java Virtual Machine. JVM is the engine that runs your program. What happens when we click run? Eclipse ensures the code is compiled. JVM starts execution. In our hello world example, system.out.println internally converted into bytecode, which is .class file. JVM reads the bytecode, converts it into machine code, and it displays the output. Why JVM is important? Because it is platform independent. Same program runs on Windows, Linux, Mac. It handles the memory management automatically. Garbage collection removes unused objects. Security checks code before execution. Simple line: JVM runs your program. JRE, Java Runtime Environment. It provides environment to run Java programs. In Eclipse, you can see JRE system library. That means Eclipse is using JRE. What is inside JRE? JVM, Java libraries. In our hello world example, system.out.println hello world. Here, system is class, println is a method. These comes from Java libraries inside JRE. What JRE does? It loads the required classes, provides libraries, and starts JVM. JRE cannot create programs, it only runs programs. Simple line: JRE provides environment to run program. JDK, Java Development Kit. It is used to develop Java programs. In Eclipse, when you write code, JDK is used. When you save, compilation happens automatically. What JDK contains? Compiler, tools, JRE. In our hello world example, when you save a file, Eclipse compiles code, create .class files internally. Why JDK is important? Without JDK, Eclipse will not work. No compilation, no execution. Simple line: JDK is used to build program. Now let's clearly understand how all three work together. Step 1. You write code in Eclipse using JDK. Step 2. When you save, JDK compiler converts code into bytecode. Step 3. When you click run, JRE provides environment. Step 4. JVM takes bytecode and executes it. Step 5. Output is shown. Simple flow. Inside JDK, we have JRE. Inside JRE, we have JVM. Final understanding. JDK build program. JRE runs program. JVM executes program. Important note: we are using Eclipse here, but same process happens in all IDEs: IntelliJ IDE, VS Code, NetBeans. Only UI changes. Internal working is same. Today we learned what is JVM, what is JRE, what is JDK, how they work together. In the next video, we will understand how a Java program runs step by step in detail. If you like this video, like, share, subscribe to SP Learning Labs. See you in the next video. Welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about identifiers in Java. We will understand what identifiers are, why they are important, rules for identifiers, and naming conventions. So, let's get started. In the previous video, we learned how a Java program runs. We understood the flow like first, we write code in .java file. Then it gets converted into .class file. After that, JVM executes it. And finally, we get the output. We also discussed compiler, interpreter, and JIT. Now, we are moving into actual coding basics. Now, the question is, when we write Java programs, how do we name things? Let's understand this with a simple example. In a classroom, a student has a name. In a company, an employee has an ID. In a shop, a product has a name. Now think, why do we need these names? Because without names, we cannot identify things properly. It becomes confusing. Now the same concept applies in Java. When we create variables, methods, classes, we must give them names. And these names are called identifiers. Now let's understand this practically using code. Now we will use the same Java project to write our identifiers. Here you can see beginners. Click on this package and create a new class student and select the main method and click finish. Now you can see our student class has been created. Now look at this program. Here you can see the class name student. This is a class identifier, and inside this class I have a main method. So this is the method identifier. Now inside this method I have student age. This is the variable identifier. So in this program we have class name, method name, and variable name. All of these are identifiers. Now when I run this, you can see the output 20. Now we will see why identifiers are important. For example, here if I type here you see I have typed int x equal to 0. Now think, what is x? Is it age, marks, or salary? Not clear, right? Now here you can see student age equal to 20. Now it is very clear that this variable is storing the student age. So always use meaningful names. This makes our code easy to understand. Now let's see the rules for identifiers. Java has some rules for identifiers. Let's see them one by one. Identifiers must start with a letter, underscore, or a dollar. Now if I type int age, this is a valid identifier. If I type int underscore count, this is also a valid identifier. And if I type int dollar salary, this is also a valid identifier. So these are the valid examples. identifier should not start with a number. Now if we see, if I type int 1 roll number, here you can see already it is showing the syntax error. Identifiers should not start with a number. So if I remove this, the error will be gone. Now spaces are not allowed for identifiers. Now you can see here I have given a space between student and name. Now it is showing error, syntax error. This means identifier cannot have spaces between words. So if I remove the space, the error will be gone. Now you can see student name. And special characters are not allowed for identifiers. Only underscore and dollar are allowed. Suppose if I type int @marks, you can see the error, syntax error. So special characters are not allowed for identifier. If I remove this, this error will be gone. Now here you can see already I have given int age. Now again I will type int capital age. I am using the same name, here also age and here also age. Only difference is here A is capital and here A is small. It is not showing any error. This is because Java is case sensitive. Both this age and this age are different identifiers. Now let's see how professionals use class names and variables. Here you can see student details. Class names use Pascal case. Each word starts with a capital letter. Now we will see variables. Here you can see variable student age. Variables use camel case. First word small, next word capital. Same for also method. Now we will see about variables and methods. Here you can see student name, which is a variable. First word small and next word is capital. This is camel case. Now I will create a method void get student. Here you can see get student. This also uses camel case. Now we will see about constants. Constants are in Java which has a fixed value. Suppose int max limit. Constants are written in uppercase with underscore between quote. So this makes code clean and readable. Now let's see some of the common mistakes. Using spaces. If you use space, it will show an error. using special chars. If I use a character here, special character, you can see the error, syntax error. And using the unclear names like x, use proper names which tells what is this variable about. So avoid these mistakes. Follow the best practices. Use meaningful names, keep names simple, and follow the naming conventions. So this is the end of code part. Alright, let's quickly recap what we learned today. First, identifier means a name in Java. These names are used for variables, methods, and classes. We also learned that identifiers must follow certain rules. And finally, we saw how to use good and meaningful names by following proper naming conventions. Now in the next video, we will learn about reserved words in Java and understand why they cannot be used as identifiers. If you found this video helpful, please like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about reserved words in Java. We will understand what reserved words are, why they cannot be used as identifiers, and different types of reserved words. Let's get started. In the previous video, we learned about identifiers. Identifiers are names given to variables, methods, and classes. Now here is an important question. Can we use any name as an identifier? The answer is no. Let's understand this with simple example. Think about traffic signals. We have words like stop, go, wait. These words already have fixed meaning. You cannot change their meaning and you cannot use them for something else. For example, you cannot say stop means go. That would create confusion, right? In the same way, Java also has some predefined words. These words have fixed meaning and we cannot use them as variable names. These are called reserved words. So exactly what are reserved words? Reserved words are predefined words in Java that already have a special meaning. Because of that, we cannot use them as identifiers. Now let's understand this practically using code. Now let's see what is reserved keywords by practically. Here I am using the same student class for our reserved keywords example. Suppose if I type here int class equal to 10. Here I am getting syntax error because class is already a reserved keyword. Here you can see we defined our student with class, so this is an reserved keyword. So we cannot use class and identifier. So instead I will use a proper name. Suppose if I keep here class number, now you can see the error is gone. So we cannot use reserved keywords as an identifiers. Now let's understand different types of reserved keywords. Java uses reserved words for different purposes. Let's see them one by one. Data type keywords. In Java, there are different data types like int, byte, short, float, double, char, boolean. Here you can see already we have used int. Now let's create an identifier with integer data type. Here you can see I am getting an error, invalid variable declaration, because int is an data type keyword. We cannot use int as an identifier. Like this, if I use boolean, see here also I am getting error because we cannot use boolean as an identifier because it is an data type keyword. So if I remove this, the error will be gone, and if I remove this, the error will be gone. So int is used for identifiers, double is used for decimal values, and boolean is used for true or false. So we cannot use data type keywords as an identifiers. Now we will see about conditional keywords. Now here you can see if, else. These are conditional keywords. These helps us make decision in a program. If checks a condition, else handles the alternative cases. So these are the part of Java logic. So they cannot be used as identifiers. Suppose if I try to create an identifier, you can see it is showing the syntax error because we cannot use an conditional keywords as an identifiers. Now we will see about loop keywords. Don't worry about this conditional and loops. We will learn about this in detail in the coming videos. Here you can see for. This is an loop keyword. We cannot use for as an identifier. Suppose if I try to create I am getting error because for is an loop keyword. We cannot use this an identifier. Now we will see about class and object keywords. We have already tried this example. Here you can see I am getting syntax error because class is used to define a class. So we cannot use this keyword as an identifier. Now we will see about object. Here I will take the student details. In Java, object is created by using new keyword. Here you can see I use new. So if I try to create any identifier with the name new, I will get an error. These are the core Java keywords. So they cannot be used as an identifiers. Now remember this important rule. Reserved words cannot be used as an identifiers. So this is the end of code part. Here are some simple tips. Do not use keywords as names. Use meaningful identifiers. Follow naming conventions. If you get any error, check if you used a reserved word. Let's quickly recap. Reserved words are predefined. They have special meaning. They cannot be used as identifiers. Before we end this video, I have a small task for you. Try to find out how many reserved words are there in Java. Mention your answer in the comments. In the next video, we will learn about data types in Java, which is one of the most important concepts in programming. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about data types in Java. In this session, you will understand what data types are, why they are important and different types of data types in Java. Let's get started. In the previous video, we learned about reserved words in Java. Reserved words are predefined keywords like int, boolean, class, public. Now here is an important question. We saw keywords like int, float, boolean, but what exactly are these? These are data types. Think about packing for a trip. You wouldn't put your gold jewelry in a water bottle or water inside a suitcase. Every item needs the right container. In Java, it's exactly the same. Every type of data needs the right data type. What is data type? A data type defines what kind of value a variable can store, how much memory it will use, what operators can be performed. Let me explain this with simple examples. If I want to storage, I use a number type. If I want to store price, I use decimal type. If I want to store true or false, I use boolean type. If I want to store a single letter, I use character type. So, depending upon the data, we choose the data type. Why data types are important? Prevent storing wrong data, improve performance, optimize memory usage, ensure type safety. Choosing the correct data type is very important in programming. Before we move further, in Java, data types are divided into two categories: primitive data type, non-primitive data type. Primitive data types are simple and built-in. Non-primitive data types are more complex like string, array and objects. In this video, we will focus on primitive data types. Java provides 8 primitive data types: byte, short, int, long, float, double, char, boolean. These are fast, memory efficient, basic building blocks of Java program. Now let's understand this practically using code. We will see how each data types work step by step. Don't worry if you are new, just focus on understanding. Now I will open Eclipse IDE. And I will select this workspace. You know about workspace, right? Workspace are where our projects get stored. Click on this launch button. Now inside this src folder, you can see our package beginners where we have created hello-world.java file and student.java file. Now we will create a new package. Click on new and select here package and keep data type here and click finish. Now our data type package has been created. Now inside this package I will create a new class, primitive data type. Now I will click the main method and click finish. Now you can see our primitive data type class is created and also the main method. So every class should contain a main method to run. Now we will go step by step and see how each data type behaves. Don't worry if you are new, just focus on understanding and observe carefully when error happens. That's where real learning is. Now let's talk about whole numbers like byte, short, int, and long. Now I am creating a variable of type byte and assigning a 100 value to it. So now we will print this value. Today I will also show you one shortcut how to print system.out.println. Just simply type sysout and press Ctrl spacebar. Now you can see system.out.println and I will keep B here. Press Ctrl S or you can see here save option. Click on this. Now click on the right click. Here you can see run as Java application. Now you can see 100 is printed here. So this is about byte. Byte is the smallest integer data type. It ranges from -128 to 127. Now here I will create another byte variable. Now here you can see the error. Why this error is coming? Because 130 is outside the allowed range. Java does not allow the invalid data. So Java doesn't wait until runtime. It stops you at compile time. This is compile time error. Now if I change this value to 127, so this is between the byte range. So the error is gone. Now we will move on to the short. I have created a variable s of type short and I have assigned 1000 to it. Now we will print this. Save and run as Java application. You can see the output 1000. Here s is the bigger than byte and its ranges from -32,768 to 32,767. So this is about short. Now I will create another short variable. Now I will use minus here. Here also you can see the error because this is not in between the short range. It is exceed the limit. So this error is coming. Now if I change 4 to 3, the error is gone. So because the value exceeds the allowed range. This is about short. Now we move on to the int. and we will print this. Save the file and run as Java application. Now you can see int value is also printed. So int is the most commonly used data type. Its range from minus 2.1 billion to plus 2.1 billion. So big, right? It's approximately around minus 2,147,000,048,36482 plus 2,147,000,048,32647. So this is about int. Now we will create another int variable. Two one four seven 483648. Now you can see the error here. Now you can see the error. It is above the int range even though we have just given one number extra. So Java throws an error. Even if you exceed by 1, Java won't allow it. Now it works fine. Now let's move to long. Now you can see I have created a variable of type long, but I am seeing an error here because Java treats numbers as int by default. This is a large value. So if I add L at the end, now this will treat as long. Now I will try to print this one also. Sys out. Run as Java application. Now you can see the all byte, short, int and long values. Now we will move on to the decimal numbers like double and float. Now I have created a variable of type double and the variable is price and I have assigned a value 10.9928. Double is default type of decimal value. Now I will print this. Click on write and click run as Java application. Now you can see double value also printed. Double is default type of decimal values. Now we will move on to the float. Now here I have created a variable of type float and the variable name is price2 and I have assigned 10.99 to it. Now this gives an error. Why? Because Java treats decimals as double by default. So by adding the f here, the error will be gone. Now this tells Java this is a float value. Now it works. Now I'll print this. Here I have created a variable of type char and the variable name is grade and I have assigned the value a to it. Char stores a single character and always use single quotes. If I use double quotes, you can see the error because double quotes means string, not char. Java does not allow this. Now the error is gone. Now we will try to print these values. Now we will move to our last data type boolean. Here I have created a variable of type boolean and the variable name is checked and I am assigning the value true to it. Boolean can only have two values, true or false. Now I will print this. Now you can see true is printed in the console. Now I will create another boolean value. Now here I am getting an error because this is a string. Anything inside a double quotes Java treats as string. So this is not a boolean. Now it works. Now you can see the false. So finally Java is strict because it checks everything before executing. It prevents wrong data, catches errors early, and that's what makes Java reliable and safe. So this is the end of code part. Alright, let's quickly recap what we have learned today. What are data types? Why they are important? Types of data types. We will explore each type more deeply in upcoming videos. Before we end this video, I have a small task for you. Find out what are the default values of primitive data types in Java. Mention your answers in the comments. In the next video, we will learn about non-primitive data types like string, array, and objects. If you found this helpful, please like, share, and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about non-primitive data types in Java. In this session, you will understand what non-primitive data types are, why they are important, different types of non-primitive data types. Let's get started. In the previous video, we learned about primitive data types. These are basic data types like int, double, char, boolean. These store simple values. Now here is an important question. Can we store complex data like a name, a list of marks, or a student object using primitive data types? The answer is no. Think about this. Primitive data types are like small boxes that can hold only one item. But what if you want to store a list of items or complete student details? You need a bigger and smarter container, and that's where non-primitive data types comes in. Non-primitive data types are more complex, can store multiple values, can have methods unlike primitive data types. They do not store actual values directly. Instead, they store a reference memory address. Simply, primitive stores value. Non-primitives stores reference. There are different non-primitive data types: string, array, class, object, interface. Now let's understand this with simple examples. Now let's see about non-primitive data types. Here I will create a new class in the same data type package. And I will click on main method and click finish. Now you can see our non-primitive data type class has been created. String is used to store text data like names or messages. Here I am storing my name inside a variable called name. Now let's print it. You know how to print the value, right? Right click, run as Java application. Now you can see the output Naveen. Now we will move on to arrays. So this is how we declare an array. Now suppose I want to store multiple values like marks. Instead of creating multiple variables, we use array. Here I created array of marks. Now I will try to print the first value using index. So 0 means it will print the first index value of an array. Now you can see the output 80 because we mentioned here 0. It will print the first index of an array. Now let's move on to class. Here I will create a new class. Now inside this class, I will just keep two variables, int id and string name. Say this. So a class is like a blueprint. It defines properties of an object. Student is a class. It has id and name. This is also a class. Now let's move on to object creation. Now I will create object for this student class. So this is the object creation for a class. Object is the real instance of a class. Now I will assign some values to this id and name. Now let's try to print these values. Save and run as Java application. Now you can see the output 101 and Rahul. These are the values we have assigned to id and name. So here we used string, array, class and object. All these are non-primitive data types. They help us store complex and structured data. Right now, don't worry about understanding everything deep. Each of these topics like string, array and object are separate concepts. We will learn each one in detail in the coming videos step by step. As of now, remember these are non-primitive data types. So this is the end of code part. Now quickly summarize the core difference between primitive and non-primitive data types. Primitive data types store actual value directly, simple and fixed. Non-primitive data types are stores reference used for complex data. Now let's connect this with a real world scenario. Imagine you are building a student application. We store student name as string, student marks as array, complete student details as object. So based upon the requirement, we choose the data type. Simple data, primitive, complex data, non-primitive data type. Alright, let's quickly recap what we learned today. What are non-primitive data types? Different types like string, array, object. Basic understanding of how they work and how they are different from primitive data types. Before we end this, I have a small task for you. Identify which data type should be used for storing a name, storing multiple marks. Drop your answers in the comments. In the next video, we are going to learn about literals in Java, which is very important concept to understand how values are actually written inside programs. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about variables in Java. We will understand what variables are, types of variables, memory storage, initialization, and common mistakes. Let's get started. In the previous video, we learned about identifiers, data types, and literals. Identifiers are names we give to things like variables, methods, and classes. Literals are values. Example, int age equal to 25. Here, age is an identifier. 25 is literal. Now, when we combine this, data type plus identifier plus value, that becomes a variable. Variable is just an identifier that stores a value. Think of variable like a named box. You store something inside it and you give it a name. For example, imagine you have a box labeled score. Inside that box, you put the value 100. After some time, the score updates and the value changes to 150 and then 200. But the box name score remains the same. Same thing happens in Java. We create a variable, give it a name, and store a value inside it. The name stays the same, but the value inside keeps changing. So in programming, variables helps us store values that can change over time. What is variable? A variable is a place where we store a value. It has a name and it holds some data. Now let's see this practically. Now let's create a class variable. Check on the main method and click finish. Now you can see our variable class has been created. Now we will start writing code inside this method. Here I will write int age equal to 25. Now here you can see int is data type, age is identifier, and we have assigned 25 value to it. This is literal. Now I will print this. Now you can see the output 25. So what internally happens? Java creates a memory, stores 25 and labels it as age. Now let's see this. Now you can see the output 25 and 30. Here now I am changing the value. That's why it's called variable, because value can change. Now let's see different types of variables. In Java, we have three types of variables: local variable, instance variable, static variable. Now let's see each one of them. Here you can see I have written a variable inside a method. So a variable declared inside a method is called local variable. This will be local variable. So local variable must be initialized. What if we not initialize? Let's see that. Suppose I will remove this. Now here you can see the error. The local variable age may not have been initialized. So Java will throw compile time error because local variables must be initialized. Java will not provide default values for local variable. Now this will store in stack memory and local variables must be initialized. Now let's look into instance variable. Instance variable are declared inside the class but outside the method. So this is inside the class, and here I will type. So this is instance variable. Now I will use this instance variable. Here I am getting error because we cannot use instance variable directly. To use instance variable, we must create an object. We must use new keyword. Now you can see the error is gone. If I run this, now you can see the output 0. Why it printed 0? Because for int 0 is the default value. If we not initialize, it gives the default value. So why this worked? Because instance variables are belong to class. So this will stored in heap memory. So objects are stored in heap memory. So this belongs to class. So we must create an object and access the instance variable. Now we will see static variable. Static variable is shared across all the objects. Now I will access this variable. So a variable declared with static keyword is called static variable. Now you can say I am not getting any error because it is shared across all the object. We don't need to create object to access the static variable. Now if I run this, now you can see the output ABC. So static variable can access directly without creating object. It is stored in method area. So what is about initialization? Initialization means giving value. Why needed? Java knows what value to use. Local variables must be initialized. Others get default values. If I keep here, if I run this, you can see the null value because string it gives the null as default value. Now let's look at some common mistakes. Here we have written int age equal to 25. If I keep here 25.0, it will give error because integer cannot store decimal. Now local variable must be initialized because Java does not provide default values for local variables. So remember, variable name equal to identifier. So all identifier rules apply here. So this is the end of code part. Now we will see the best practices. Use meaningful names like age, salary. Follow naming rules. Match correct data type. Initialize variables properly. So today we learn what variables are, identifier plus literal connection, types of variables, memory storage, initialization, common mistakes. Before ending this video, I have a small task for you. Try to find out how many types of memory are there in Java and what does each memory store. Why should we initialize local variables? Mention your answers in the comments. In the next video, we will learn about where arg methods in Java, how to pass multiple values and write flexible methods. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about where args methods in Java. We will understand what are where args, why we use them, how they work, rules and common mistakes. Let's get started. In the previous video, we learned about variables in Java. A variable is used to store a value. It has a name and a value. Example, int age equal to 25. Here, age is variable name, 25 is value. Now think, what if we want to pass many values? Not just one value. This is what we are going to solve today. Let's understand this with a simple example. Imagine you have a shopping bag. You can put one item, you can put 5 items, you can put 20 items. The bag changes based on how many items you add. It does not have a fixed limit. In Java, where args works the same way. A method can take one value or many values. It depends on what we pass. Where args means we can pass any number of values. Where args means variable arguments. It allows a method to take any number of values. Instead of writing many methods, we write one method. One method can handle many values. Now let's see this practically. Now let's write a simple method for this. Watch carefully. Now I will create a new class. I will give class name as whereArgsDemo. And I will check the main method and click finish. Now you can see the main method is already created. So we don't need to write manually. Now inside this class, I will create a method. Here I have created a add method. Inside brackets, I have written int numbers. These three dots means it can take many values. Numbers is the variable name. Now inside this method, I will write code. Here you can see now I am printing total number of values. Number's length gives how many values we passed. Now here I will write a condition. Now I am checking at least one value is there. Now inside this I will print here I am printing first value. Numbers of 0 means first value. Now here I will write another condition. So now I am checking if more than one value is there. Now inside this I will print here I am printing the second value. Numbers of 1 means second value. Now this is our method. Here I have written two conditions. First condition, it prints first value if the length greater than 0. And second condition, it prints second value if the length greater than 1. Now I will go to the main method and call this method. Here this is our main method. Here I will call add and pass 10, 20. Since this is static method, we can directly call. And next I will call again add method and I will pass 5, 15, 25. This time I am passing 3 values. Save and now I will run this program. Now you can see here total values equal to 2 and first value equal to 10 and second value equal to 20. Here first method is called, we are passing 2 values, that's why here total values equal to 2 and here we passed 10 as the first value. So first value 10 and second value 20. So here one method is handling different number of values. This is the power of varargs. Varargs allows a method to take any number of values in a simple way. Here also you can see we called again add method and passed 5, 15, 25. Here you can see total value is 3, first value is 5 and second value is 15. So only one varargs is allowed in a method. Now let's try to create 2 varargs. Now you can see the error here because we cannot pass multiple varargs to a method. Now you can see the error is gone. And where x must be the last. Here in this method, if I keep another variable, you can see the error already, because where x must be the last parameter in the method. Now you can see the error is gone. And here we must pass that's it, the error is gone. So remember two things. Only one where x is allowed per method, and it must be always the last parameter. Now let's see some common mistakes. These mistakes are very important for beginners. Suppose if I forgot this, now here I am writing int numbers, but I forgot the three dots. Now this is just a normal parameter, not varargs. So this method cannot take multiple values. Confusing with array. Here if I keep instead of dots array, this is an int array, not an varargs. It looks similar but looks different. Here we must pass array manually. So varargs is actually an array internally, but Java makes it easier for us. We don't need to create array manually. Varargs is like an array, but simple to use. Now let's see some of the best practices. Use varargs when values are not fixed. Keep methods simple and use meaningful names. So this is the end of code part. Today we learned what is varargs, how it works in code, rules and mistakes. Before ending this video, I have a small task for you. Try to create a method using varargs and print the last value. Try to access the last index. Also, what happens if no values are passed? Will it give error or not? Try it in your IDE and write your answers in the comments. Practice is the key. Try it yourself and understand better. So that's all for today. In the next video, we will learn about main method in Java. We will understand how a Java program starts and why main method is important. If you found this helpful, please like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about main method in Java. We will understand what is main method, why it is important, real world use, rules, common mistakes, best practices. Let's get started. In the previous video, we learned about varargs methods. We saw how one method can take multiple values. Now today, we are learning something very important. Without this, Java program will not run. Every Java program needs a starting point. Let's understand this with a simple example. Imagine you want to enter a house. You must enter through the door. You cannot enter from anywhere. In Java, main method is that door. Java enters the program through that main method and starts execution from there. Main method is the entry point of a Java program. Why is main method important? Because program starts from here. Without main method, program will not run. JVM looks for main method first. No main method, no execution. In real projects, main method is used to start applications. Example, Spring Boot applications, console applications, any Java program, everything starts from main method. Main method is like a start button. Now, let's see this practically. Now, let's write the Java program and understand what the main method is, because this is where every Java program begins. Now here I am creating a new class, main demo. Select the main method and click finish. Now you can see our main demo class has been created with the main method. Now here main method is automatically created. We can also write main method using shortcut. Just type main and press Ctrl plus spacebar. Now you can see the option main method, select and press enter. Like this also we can create the main method using shortcut. Now inside this main method I will print a statement. Now this is our main method. This is the starting point of the Java program. When we run this, Java virtual machine starts execution. JVM will look for main method first. It finds the main, program starts. If not, program will not run. So main method is like entry gate. Now this part, string array args. This is used to take input from command line. We can pass values while running the program. So for now just remember it is used for receiving inputs from outside the program. Now I will run this program. Now you can see the output hello Java. This line system.out.println hello Java. It is used to print output on console. Whatever we write inside these double quotes will be displayed. Before Java 21, we had strict rules for main method. It must be public, static, void, main with string array args. We had to remember all this. But now Java is becoming simplest. After Java 21, many changes happened to main method. Let's see step by step. First, remove static. First, I am removing static. Earlier, JVM needed this. Now Java can create object automatically. So static is not required in the new style. So if I run this, you can see the output hello Java. So you can see it's still working. Program is running successfully even without static. So this confirms in modern Java static is not mandatory for main method. But remember, this works only in newer Java versions. Now let's move to the next step. We will remove string array args. Here I have removed string array args. So Java made it optional. Now if I run this, you can see it's still working. And if I run this, now you can see the output hello Java. So Java made it optional. You can see it's still working. Program is running successfully even without string args. So this means arguments are not mandatory in the new style. But remember, if you want to take input from command line, then we need string args. Now next move to the next step, removing public. Now I removed public. Access modifier is also not required here. If I run this, now you can see the output hello Java. Program runs successfully even without public. So in this new style, public is also optional. But remember, in real applications, we usually keep proper access modifiers. Now let's move to the next step, changing the return type for main method. Now question is, can we use int instead of void? Answer is no. Main method should not return anything. JVM does not expect any value. So it must be void only. Now here I will remove void and keep int. I will add here return 0. And if I try to run this, you can see there is no Java application option because here it is not treating this as main method because the return type is int. So it must be always void. Now you can see the option run as Java application. So finally, this is the simplest version. No static, no args, no public, just clean code. If I run this, you can see it is working. And prints hello Java. So now writing Java code becomes much easier, less syntax, more focus on logic. But remember, this is mainly for learning and quick programs. In real applications, we still use traditional main method. So this is the end of code part. Now let's talk about some common mistakes. These are very small mistakes but very important. Many beginners do these mistakes. First, changing the main method name. Instead of main, writing something else. Then the program will not run. Next, removing static. If you remove static, Java cannot call the method. Changing the parameters like removing string array args or writing something else. This will also break the program. And sometimes small syntax mistakes like missing brackets or wrong keywords. Even a small mistake program will not run. So always be careful while writing main method. Now let's see some best practices. This will help you write clean code. First, always use correct syntax. Don't try to modify main method structure. Next, keep main method simple. Don't try too much logic inside it. Instead, create separate methods and call them from main method. And also use meaningful print statements so that output is clear and easy to understand. Main method should be simple, clean, and easy to understand. Now before we end this video, I have one interesting question for you. This is something you should explore on your own. First task. Create a simple Java class and print your name using main method. Next, try to find out how many different ways we can write main method. Can we change order? Can we use different syntax? Try different combination in your IDE and see which one works. Also, try removing static. What error did you get? Write your answers in the comments. Try it yourselves, that's how you really learn. So that's all for today. In the next video, we will learn command line arguments, how to pass values to main method. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about command line arguments. You will understand what are command line arguments, why we use them, how to pass values, and common mistakes. Let's get started. In previous video, we learned about main method in Java. We saw this part string array args. Today, we will understand what is this args really means. Command line arguments are inputs given to main method. Let's understand this with a simple example. Imagine you are ordering food online. You select items like burger, pizza, juice and place the order. These items are inputs you are giving. In the same way, in Java, we can give input while running the program. Those inputs are called command line arguments. Now let's see this practically. Now I will create a class command demo. And check on this main method and click finish. Now you can see here our command demo class has been created. Now inside this main method, I will print two statements. Here args is an array. It stores values we pass while running program. Here args of 0 gives first value and args of 1 gives second value. Now I will run this program. Here you can see two options, Java application and run configurations. We will click run configurations and here you can see arguments option. Check this, it is selected for the same class or not, and here you can see two options, program arguments and VM arguments. Don't get confused, we will use the program arguments. Whatever we type here just goes to the args. Here I will pass hello space 100 and apply and click on run. Now you can see the output, first value hello and second value 100. So program arguments go into the string array args. Now let's try something different. Instead of typing hello space 100, we will pass hello comma 100 and let's see what happens. Here I will remove the space and pass comma in between and run. Here you can see the output. First value hello comma 100 and next we are getting an exception which is index 1 out of bounds for length 1. This is because here hello comma 100 is passing as an 1 value and it is coming here, and for this arguments 1 there is no value passed, so it is giving this error. Now if I go there, here in the arguments, if I pass now you can see first value as hello comma 100 and second value 200. So space separate values, comma does not. Important things to remember. All values are stored as string. Index starts from 0. Args.length gives total values. Now let's see some common mistakes. First, not passing values and trying to access args0. Like here, we got error previously when we tried to access args1 because we did not pass the value in the correct index 1. So we got error. And accessing wrong index. Suppose if I type here and save, now here we are passing hello comma 100 space 200. Here we are passing two values. There is no third value. Now if I run this, you can see the error. For the third statement we are getting error because we are trying to access third value. So we are getting an error. Always check arch.length before accessing values. So this is the end of code part. Now let's talk about some best practices. This will help you avoid errors and write better code. First, always check how many values are passed using arch.length. Don't directly access value without checking. Next, remember all values comes as string. So if you need numbers, convert them. And also try to print output in clean way so that it is easy to understand. Write safe code, check values and keep output clear. Now it's your turn to practice. Try this small task. Create a simple program, pass your name and age and print both values. Then convert age into integer and add 10 to it and print the result. Next, try something interesting. Instead of space, use comma like name comma age and see what happens. Also, try running your program using command prompt. Pass values from there and observe how it works. Try all this in your system and write your answers in the comments. Practice it yourself, and that's how you really understand coding. So, That's all for today. In the next video, we will learn operators in Java, how we perform operations. If you found this helpful, like, share, and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about operators in Java. We will understand what are operators, types of operators, why they are important, real world use, and common mistakes. Let's get started. In the previous video, we learned about command line arguments. We saw how to pass values to a program. Now we have values, but just having values is not enough. We need to work with them. We need to calculate, compare, and update. To work with values, we use operators. Imagine you go shopping. You buy items worth 100 and 200. You calculate total 100 plus 200 equal to 300. Here, plus is doing the work. That is called an operator. In Java also, operators helps us do work on values. Operators are symbols used to perform operations. There are different types of operators: arithmetic, relational, logical, assignment. We will understand each one step by step. But before that, let's understand why operators are important. In any program, we don't just store values, we also perform operations like calculating total price, comparing marks, checking conditions, updating values. In real applications, like in banking apps, we calculate balance. In shopping apps, we calculate the bill. And in logging systems, we check conditions. Without operators, we cannot write logic. Now let's see each one by writing code. Now let's see operators. First, arithmetic operators. I will create a new class. I will name this class as operator and check on the main method and click finish. Now you can see our operator class has been created with main method. Now inside this main method, we will start writing code. First, arithmetic operators. These are used for calculations. Here I am writing two variables, a with 10 and b is 5. Now I will write a print statement. Here I will write a plus b. Now see here we are using plus symbol. So plus is used for addition. Next we will print another statement. Here we are using minus symbol. Minus means subtractions. And next we will use star. Here we are using star. This is used for multiplication. Now here we are using slash. This is used for division. And next here we will use modulus. This gives the remainder. So these are the arithmetic operators. We all learned this in our basic maths. Now save this and run as Java application. Now you can see the output 15 for addition and 5 for subtraction and 50 for multiplication and 2 for division, and here the remainder is 0. Now let's look at increment and decrement operators. Plus plus is used for increase value by 1 and minus minus is used to decrease value by 1. Here we have two types of increment, post increment, pre increment, and also we have two types of decrement, post decrement and pre decrement. Let's see each one of them. Now I will write int x equal to 10 and I will print a statement. Here we are using x plus plus, which means this is post increment. Now what do you think? Increase happens before or after printing? Let's see this. I will save this and I will run as Java application. Now you can see the output here x plus plus 10 and x 11. So first it printed 10, then value increased to 11. So x plus plus means first use then increase. Next we will see pre-increment. Here you can see we are using plus plus before y. This is pre-increment. And let's run this and see the output. Now here you can see the output 11. So before running this, I will comment these statements, so we will not get confused. And save and run as Java application. Now you can see the output 11 and 11 because here it increased before the print statements. So here we are seeing 11. So now y becomes 11. So here it is printing 11. So this is pre-increment. Now let's see decrement. So here we are using minus minus after p. This is post decrement. Now think what will be the output. Let's run this. You can see here it is post. So here we can see 10. Afterwards it become 9. One value decreased. And you can see here 9. So this is post decrement. Now we will see pre decrement. First we comment this. So here we are using minus minus before q. So this is pre decrement. Now just guess what will be the output. Here we are decreasing pre, means here the value 10 will become 9, and so here also it will become 9. Let's see what will be the output. Save this and run as Java application. Now you can see the output 9 and 9. So plus plus means increases, minus minus means decreases, and position matters where we are keeping that, before or after. Now let's look at relational operators. These are used to compare values. I will comment this. I will use print statement A with this symbol, and here this symbol means, you know, right, this is used for greater than. And next we will print another statement, and here we will use less than. This is used for less than. And then we will use another statement for equal to. This represents equals to. And we will add another statement and we will use not equal to. So this is not equal to. Now we will save this and see the output. Here you can see the output: true, false, false, and true. Let's see this. Here we have written A is 10 and B is 5. And here we used A greater than B, means 10 is greater than 5. And also here A less than B. Here 5 is less than 10. And here you can see A equal to B. This means 10 equals to 5. This is wrong. So we can see here false. and here you can see A not equal to B, means 10 is not equal to 5. So here we can see true statements. So these always return true or false. Now we will see logical operators. I will comment this. So logical operators, these are used to combine conditions. Let's say print a statement. Here we are using and. This means this is the logical operator. Now let's print another statement. So this is OR. And means and this means OR. So let's run this and see the output. Now you can see the output true and true, because here and means both must be true. Here you can see A greater than 5. This is 10 greater than 5, true, and B less than 10. 5 is less than 10, because this is also true. So here true and true becomes true. That's why in the console we are seeing true. And we will see the next statement. Here you can see A greater than 5. This means true. And here you can see B greater than 10. This is false. Here OR means either one of the statements must be true. That's why here we are seeing true. Now let's move to assignment operators. These are used to update values. I will also comment this. Now see here, we are using plus equal to. This means we are adding and assigning, which this is equivalent to z equal to z plus 5. And now let's run and see the output. Now here you can see the output 15. Here we are adding 5 to z, which is equivalent to z equal to z plus 5. That's why we are getting 15 in the output. So assignment operators makes update simple and easy. Now let's see some of the common mistakes. Here you can see we are using A equal to B in this statement. So here if I remove one equal to, save and run. Now you can see the output 5. Why? Because here we are telling A equals to B. This means A becomes 5. Here B value is 5. So here A becomes 5. So equal to is used to assign value. Equal to is used to compare values. Next, getting confused with plus plus operator. Post increment and pre increment. Not understanding whether the value increases before printing or after printing. So always remember x plus plus means first use then increase, and plus plus y means first increase then use. Another common mistake, not using not equal to correctly. This means not equal to. Sometimes beginners confuse it with. Always remember not equal to is used for comparison. It checks if two values are not equal. One more mistake, confusing logical operators. And means both should be true. Or means at least one value should be true. So using them incorrectly can give wrong results. Understand each operator clearly and then your logic becomes easy. So this is the end of code part. Now let's see some best practices related to operators. Always use the right operator for the right situation. Don't mix assignment and comparison. When using operator, be very clear whether you need pre-increment or post-increment. Avoid writing complex expressions like multiple operators in one line. Keep it simple and readable. And very important, always test your logic with different values because operators may behave differently based on the condition. Understanding operators clearly makes your logic strong. Before ending this video, I will give a small task. Try this on your own. First, create a Java program. Take two numbers, any values, then perform all arithmetic operations, addition, subtraction, multiplication, division, and remainder. Next, use both post increment and pre increment. Print the values and observe the difference carefully. After that, use relational operators. Compare the two numbers, print the results true or false. Then use logical operators. Try conditions like both true and at least one true or. Finally, use assignment operators. Update a value using operators like plus equal, minus equal, and multiply equal and print the final result. Write all outputs clearly and add comments explaining what you understand. The more you practice, the stronger your logic becomes. Try it yourself and don't skip this part. So that's all for today. In the next video, we will learn about flow control in Java. What is flow control, different types of flow control statements, and how a program controls the execution step by step. This is very important topic to understand. If you found this helpful, like, share, and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about flow control in Java. Flow control means controlling how a program executes step by step. It mainly has three types: decision making, looping, and jump statements. In this video, we will focus on decision making in Java. We will understand what is decision making, types of decision statements, why they are important, real world use, and common mistakes. Let's get started. In the previous video, we learned about operators. we used symbols like greater than, less than, and equal to compare values, and also logical operators like and or to combine conditions. Operators helps us check conditions. Before we understand this, let's look at a simple real life situation. In real life, we make decisions every day. If it is raining, we take an umbrella. If we have money, we buy something. If we pass exam, we celebrate. Same way in programs, decisions are based on conditions. If condition is true, do one thing. If false, do something else. Programs things using conditions. What is decision making? Decision making means executing different code based on conditions. In Java, we use if else if, nested if, switch. Now let's understand why this is important. In real programs, we need to take decisions based on data like checking user eligibility, validating login details, deciding what to display. Without decision making, programs cannot react to different situations. Decision making makes programs intelligent. Now let's understand each one with syntax and code. Now we will see decision making. I will create a new class. Decision making. And check on the main method and click finish. Now you can see our class has been created with the main method. Now inside this main method, we will write our code. First, we will see the if statement. If statement is used to check a condition. And let's see the syntax. So this is the syntax for if. If with block, and inside this we will be writing condition, and this is the code. Now let's see this. And inside this condition we will print a statement. Now look at this. Here we are checking age with 18. Here we are using age greater than or equal to 18. This means age must be equal to 18 or greater than 18. If it is true, this statement will be printed. Now let's check this. Now you can see the output eligible to vote. So it runs only when condition is true. Now let's look at if else. So if else is used when we have two choices. And let's see the syntax. So this is the syntax for if else. First, it will check the condition. If it is true, this true block will get executed, and if it is false, it will comes to the else block and this false block will get executed. Now let's see this. I will write if age greater than or equal to 18, print eligible. Else I will print not eligible. Save this and run. I will comment this. Again run. Here we are seeing output as eligible based on the condition. So here it is because age is greater than 18. Here we can see 20 and it is greater than 18. So we are seeing this eligible in the console. So if else helps us choose between two outputs. Now next move to else if ladder. So else if is when we have multiple conditions. Let's look at the syntax first. If condition, open the block, here code, and again we'll have else. Again here we will have another condition. This is condition 1 and make this as condition 2. And last we will be having else. Here code. So this is the syntax for if else if ladder. Now let's see this. Here I will use new variable int marks equal to 75. Now here I will write one condition. Now if marks greater than or equal to 90, I will print grade A. Otherwise, I will write another condition. If marks greater than or equal to 70. If this becomes true, I will print another statement. Grade B. And last, if nothing is true, print this. Here we are printing grades based on marks. Let's run this and see. Now you can see the output grade B because here we have given marks equal to 75. So this condition gets satisfied and grade B is printed in the console. if I change the value and run again, you can see the output 70 because here we have written greater than or equal to. So this condition satisfies. Now I will use here 60 and run. You can see the output fail. So this how if else if ladder works. Now let's move to the next one, nested if. So nested if means if inside another if, used when we check multiple conditions step by step. Let's see the syntax. If condition 1, if condition if this becomes true, and again we will add another condition here. So if this condition 1 becomes true, go inside and check if this condition true and go inside and execute the code. This is the syntax. Now let's see this. Now here already we have int age equal to 20 and we use another field boolean has id. Now if age greater than or equal to 18, then if has id, we will print allowed to vote. Here we are checking two conditions, age and id. Now let's run this program and see the output. Here you can see the output allowed to vote because here these two conditions get satisfied. So that's why we are seeing allowed to vote output. If I keep here false, so here you can see we cannot say allowed to vote because this has become false, has no id. So this become false and this one not printed. Now let's look at the switch statement. So switch statement is used for when we have fixed values. Now let's see the syntax. We will use switch keyword. Here we will pass variable and inside this block, first case, then code, if this becomes true, it will we use break. Next again case 2, if this becomes true, break, and last default. So this is the syntax for switch statement. Now let's see this. Here I will write int day equal to 2, and now I will use switch statement. I will pass the variable name. Now inside this block, first I will write case 1. Here I will print statement. Monday. If this becomes true, I will break this. So same we will write for another 2 days. If the value is 2, it should print Tuesday. Otherwise, I will add another one. If the value is 3, print Wednesday. And last, default one. Invalid. So here we are checking the value of day and printing the corresponding day name. So let's run this and see the output. Here we have passed 2 to this day. And you can see the output Tuesday because here the value is 2, this is got satisfied and this print statement got executed. And the break, it will exit from that condition. So switch is used when we have fixed options. Now let's look into some common mistakes. Now let's look into some of the common mistakes. Here you can see we are using int greater than or equal to 18. If I remove this greater than, this is wrong because equal to is used to assign values. If we want to compare the values, we must use equal to equal to. Next mistake is missing break in switch statement. Here if I remove this break, here also I will comment this break, and here also I will comment this break. And if I run, you can see all things got executed: Tuesday, Wednesday, and invalid. That's the reason we must use break. So always check conditions and syntax carefully. Now we will look into some of the best practices. Keep your conditions simple. Write your code in a clear and readable way, and use switch when you have fixed values. Test your program with different values. So simple and clear code is easy to understand. So this is the end of code part. Before ending this video, I will give you a small task. Create a program. Check if a number is positive, negative, or 0. And one more task. Try to understand the difference between switch, if else, and else if. All are used for multiple conditions, but where to use which one? Try to think and write your answer in comments. Practice makes your logic strong. So that's all for today. In the next video, we will learn about loops in Java, how to repeat tasks multiple times. This is very useful concept in programming. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about loops in Java. We will understand what are loops, types of loops, why they are important, real world examples and common mistakes. Let's get started. In the previous video, we learned about decision making. We saw how programs take decision using if, else and switch. Decision making chooses what to do. Now let's think about this. If I ask you to print hello 5 times, what will you do? You might write it 5 times manually. But what if I ask print it 100 times? That becomes difficult. In real life also, we repeat tasks, eating daily, going to work, practicing skills. When something repeats, we use loops. What are loops? A loop is used to repeat a block of code multiple times. Instead of writing code again and again, we use loops. In Java, we have 3 types of loops: for loop, while loop, do while loop. Why loops are important? Loops are very important because they save time, they reduce code duplication, they make programs cleaner. In real programs, loops are used everywhere: reading data, processing list, running tasks multiple times. Loops helps us repeat tasks efficiently. Now let's understand each loop with syntax and examples. Now let's say loops. I will create a new class with name loop. And I will select the main method and click finish. So this is our loop class. Now inside this main method, first we will start with loops. We use a for loop when we already know how many times we want to repeat something. Now we will look at the syntax. It's very simple. We will break it step by step. Here it will be the initialization. And after this, condition. And after this, increment or decrement. So this is the syntax for loop: initialization, condition, increment or decrement. Now we will write a code. For int I equals to 1, this is the initialization, and I less than or equal to 5, this is the condition we are giving, and I plus plus, increment. Now inside this block, I will write a print statement and I will print I. Now let's understand this line by line. Here we are starting with int I equal to 1. We are saying run till I less than or equal to 5. and after every step increase by 1. Simple. Now let's run this program. And you can see the output. It printed numbers from 1 to 5. That means the loop ran 5 times. After I becomes 6, condition become false, so loop stops. So use for loops when you know the count. Now let's see while loop. We use while loop when we want to run something based on a condition. Now let's look at the syntax. It's simple and easy to follow. So this is the syntax for while loop. Here the condition check the first and the loop run based on that. Now let's see an example for while loop. We will comment this. Now inside this block I will print a statement. I, and after this I plus plus. Now let's understand this step by step. Here we are starting with I equal to 1 and we are running the loop while I less than or equal to 5. After every step it increases by 1. Very clear, right? Now let's run this program. Now here you can see the output 1, 2, 3, 4, 5. It prints numbers from 1 to 5. The loop continues smoothly as long as the condition is true and value increases step by step. While loop works based on condition. Now we will see do while loop. This loop is special because it runs the code first and then checks the condition. Now let's look at the syntax. First do while condition. So this is the syntax for do while loop. Now let's see an example. I will comment this. Now inside this block I will use print statement. While so here code runs first, after that the condition is checked. Now let's understand this step by step. Here we are starting with I equal to 1. First, the code runs and prints the value. Then condition I equal to 5 is checked. After each step, I is increased by 1. Simple. Now let's run this program. Now you can see the output 1, 2, 3, 4, 5. Here it prints numbers from 1 to 5. The loop runs once first and then continues based on the condition. Do while runs first, then check condition. Now you might notice something interesting. All three loops, for loop, while loop and do while loop, are printing the same output 1, 2, 3, 4, 5. So what is the difference? The difference is not in the output. The difference is how they work. For loop, we use it when we already know how many times to run the loop. Everything is written in one line: start, condition and update. And while loop is used when the condition is important. First, it checks the condition, then it runs the code. And do while loop, this one is little different. First, it runs the code, then it checks the condition. That means it always runs at least one time. Even though output looks same, the behavior is different and the use case is different. So same output but different ways to execute. Now let's look at some common mistakes. These are very important to understand. Here in while loop, we are checking I less than or equal to 5 and printing print statement I, and we are increasing I plus plus. If I remove this, I will comment this and run. Here we are printing the value, but we are not updating the I. So I always be 1. Condition I less than or equal to will always be true. Because of that, loops keep running again and again. Now let's see this. See the output here, it keeps on running again and again because we are not updating the I value. So I value will always be 1 here. So we should update this. Now let's see some of the common mistakes. Here in while loop, I will comment this. Here you can see we are printing the value I, but we are not updating the I. So I always stays 1 and condition here I less than or equal to 5 is always true. Because of that, loops keep running again and again. Now let's see this. Here you can see it's keep on printing 1 again and again because here we are not updating the I value. If I uncomment this, stop this and again I will run. So this is the correct way. Now I increases step by step. After some time, condition becomes false and loop stops properly. Now look at here. Here instead of less than, I will keep greater than. So here we are starting from I equal to 1. but the condition is I greater than or equal to 5. This condition is not matching the flow, so loop does not execute. Let's see it. You can see in the console no numbers are printed. You can see in the output nothing has been printed. So the correct way is use the correct symbol. Now condition matches the flow, loop runs from 1 to 5 correctly. Check condition and update carefully. So this is the end of code part. Now let's look at the some of best practices. First, keep your loops simple. Write code in a clean and easy way. Next, use only what is needed. Keep your logic clear and focused. Always update variables properly, so the loop moves step by step smoothly. And finally, test your program. Try different inputs and see how your loop behaves. When you follow this, your loop becomes easy to write and easy to understand. Think clearly, update properly, loop work perfectly. Now your task, write a program to print numbers from 1 to 10. And one more task, print even numbers from 1 to 20. Try using different loops, for loop, while loop. And one more important task, this is very common interview question. Print a diamond shape using stars. Try it yourself first. Think step by step how stars increase and then decrease. And one more thing, till now we used println to print values. In this program, you will also learn print method and understand the difference between print and println method. Also try different diamond pattern questions. This will help you understand loops deeply. Practice loops to improve your logic. So that's all for today. In the next video, we will learn about jump statements in Java, break and continue, how to control loops and stop or skip, execution when needed. This is very important concept. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about jump statements in Java. Jump statements are used to control the flow of loops. In this video, we will learn about break statement, continue statement, where to use them and how they work. Let's get started. In the previous video, we learned about loops. We saw how to repeat tasks using for loop, while loop and do while loop. But here is one question. What if we want to stop the loop in between or skip one step and continue with next? How can we control the loop like that? That is where jump statements come into the picture. Loops repeat, jump statements control. Let's understand with a simple example. Imagine you are searching for something. When you find it, you stop searching, and sometime you skip something and move to next. Same way in programming, we use jump statements to stop the loop or skip one step. Jump statements give control inside loops. What are jump statements? Jump statements are used to change the normal flow of loops. In Java, we have break, stops the loop, continue, skips current iteration. Let's understand with code. Now let's see the jump statements. First, let's understand the break statement. I will use this same class. Here in this for loop, we use break. Now I will use this same loop class for break statement. We use break when we want to stop the loop in between. Here I will add an condition. Now let's understand this step by step. We are running the loop from 1 to 5. Numbers will print one by one. When I becomes 3, break is executed and the loop stops at this point. So let's run this program. Now you can see the output 1 2. See, it prints only 1 2 because when the value reached 3, the loop stopped immediately. So break stops the loop at the exact point. Now let's understand continue statement. We use continue when we want to skip one step and move to the next iteration. Here I will use same I equal to 3. Here instead of break I will write continue. Now let's understand this step by step. We are running the loop from 1 to 5 and numbers will print one by one. When I becomes 3, continue is executed. The step repeat. Now let's understand this step by step. We are running the loop from 1 to 5 and numbers will print one by one. Now here when I becomes 3, continue is executed and that step is skipped and the loops moves to the next value. Now let's run the program. Here you can see the output 1 2 4 5. 3 is skipped. So continue skips one step and moves forward. Now let's understand the difference. Break stops the loop completely and continue skip only one step. Break stops, continue skips. That is the difference. So this is the end of code part. Now let's look at some common mistakes. These are very common when we start learning. First, using break when we want to skip. Break will stop the loop completely. So remaining iterations will not run. But sometimes we only want to skip one step. Next, using continue when we want to stop. Continue does not stop the loop. It only skips current step. Loop will continue with next iterations. Correct understanding. Use break when we want to stop the loop. Use continue when you want to skip one iteration. Once you understand this clearly, you can control loops easily. Use break to stop, continue to skip. Before ending this video, I have a small task for you. Write a program to print numbers from 1 to 10. In that program, skip number 5 using continue. And when the number reaches 8, stop the loop using break. And one more thing, understand the difference between break and continue. This is very commonly asked interview question. Try it step by step and observe the output carefully. Practice gives you better control on loops. So that's all for today. In the next video, we will learn a bonus concept. We will learn about debugging, how to run code step by step and understand how it actually works. This will make your programming understanding much better. If you found this helpful, like, share, and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about debugging in Java. Let's get started. Till now, we have written many programs. We used conditions, loops, break and continue. But there is one question. How do we know what exactly is happening inside the program? How values are changing step by step? That is where debugging comes into the picture. Debugging helps us see how the program runs. What is debugging? Debugging means running the program step by step and observing how the code is executing. It helps us understand what is happening inside the program and also helps us identify errors easily. Let's understand with a simple example. Before ending this video, I have a small task for you. Take any loop program, try to run it step by step and observe how values change and try with break and continue. Practice debugging to understand your code better. Now let's see how debugging works in real time. I will use the same loop example. First, I will add a breakpoint. I will click on the left side of this line next to the for loop. You can see a small blue dot. This is called a breakpoint. It tells the program pause execution here. Now I will run this program using debug as Java application. Now you can see we have switched into debug mode and the program execution passes here, and you can see many options. Here you can see variable section and breakpoints, and here you can see step into and step over. Now we will click this step over. This will do, it will move to the next line. Repeat. Now when I click on this step over, it moves to the next line. Now you can see it moves to the condition if I equal to 3. Here you can see when I hover here, you can see I equal to 1. So this condition fails. Now when I click on step over, this I will get printed with the current value. Here you can see in the console 1 is printed, and you can see here I equal to 1. Now again I will click on step over. Now the second iteration starts. Now here now I value becomes 2, and here again this condition gets failed and moves to the next line, and I will get printed. Now again I will click step over. Now here now I value is 3. Now this here you can see I equal to 3. This becomes satisfied and it will skip the current. Repeat. Now here you can see I equal to 3. Now this condition will get satisfied and it will skip the current iteration because we kept here continue statement. When I click on step over, now you can see this iteration got skipped and 3 is not printed. Now when I click step over, now I value is 4. Now this condition will not satisfied and again I will get printed. So you can see 4 in the console. Now again I will click step over. Now the I value is 5, and after this 5 will get printed. Now here you can see I value is 5. So this condition will get satisfied and it will exit from the loop. So now you can see the loop has ended. So debugging helps us clearly see how each line is executed and how values change step by step. We also see how this continuous works. Also, you can move your mouse over the variable I, it will show the current value. This makes it very easy to understand the program. Debugging shows everything step by step clearly. So, this is the end of code part. So that's all for today. In the next video, we will learn about Java file source structure, how Java files are organized, and how code is structured. This will make your Java basics strong. If you found this helpful, like, share, and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about Java file source structure. We will understand how Java files are organized, what each part means, and how code is structured. Let's get started. In the previous videos, we learned about flow control using decision making, loops, break and continue. And also, we learned about debugging, how to run code step by step and understand what is happening inside the program. Now here is one question. We are writing code, but how is this code actually organized? How does Java understand where everything is written? Before constructing a building, we don't start directly right. First, we create a blueprint. That blueprint shows where everything should be placed and how the structure should look. Same way in Java, we need a proper structure to organize our code. That is called Java file source structure. Good structure is like a blueprint for your code. Now let's understand this practically. Now let's see the Java source structure. This is the same loop program we used earlier. Now let's understand the structure. First, package. This line tells where the file belongs. Next, class. The class name is loop. File name should also be the same as class name. Here you can see our file name is loop.java. Now inside the class we have main method. This is where our execution starts. Inside main method we wrote our loop logic. This is the actual program we created earlier. So everything we write is always inside the class and main method. Your logic lives inside the class and main method. One important rule. Class name must be same as the file name. Now when we run this program, Java reads the file, finds the main method and starts execution. Then it runs our loop and prints the output. So structure helps Java understand the code and us to organize it properly. Good structure makes your code easy to manage. So this is the end of code part. Before ending this video, I have a small task for you. Take your loop program. Till now, we created classes directly by clicking options in the IDE. Now, try to explore a little. Try removing the package and see how Java behaves. Try removing imports, if any, and observe what happens. You may see some errors. That will help you understand why structure is important. And also try this. Change the package name and observe the changes. See how project structure updates. Do this step by step and observe everything clearly. This will give you better clarity. Explore more to understand better. So that's all for today. In the next video, we will learn about packages in Java, how to organize classes and group related files. This will make your project more structured. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about packages in Java. We will understand what are packages, types of packages, why they are important, real world use and common mistakes. Let's get started. In the previous video, we learned about Java file source structure. We saw how Java files are organized. Now here is one question. What if we have many classes? How do we organize them? How do we keep everything clean? That is where packages come into the picture. Packages helps us organize our code. What are packages? A package is used to group related class together. It works like a folder. In Java, we have two types of packages. Built-in packages provided by Java, user-defined packages created by developers. We will see both of these practically in the IDE. Packages helps group-related classes. Think about your computer. We create folders to store related files. Same way in Java, packages are like folders, and folders inside folders are called subpackages. Package is folder, subpackage is folder inside folder. Why packages are important? Packages are important because they organize code, avoid naming conflicts, improve readability. Organized code is easy to manage. Now let's see this practically. Till now, we created all our classes like literal, loop, operator, varx, variable, all in the same place in data type package. Now let's organize them using packages. First, I will create a new package. Click on source and select new and select package. Now observe carefully why we are using com. In real projects, we follow a meaningful format like com.companyname.project name. But you may also see names like io.projectname, org.something. These are also valid. There is no strict rule to always use com. The important thing is the package name should be meaningful and clearly represent what is inside. So when someone sees the package name, they should understand what kind of code is inside. Now let's create a package. Now here our package has been created. Before creating, let's think about the name. So what are we working on? We created programs related to loops. So I have created flow control package name. Now here you can see this loop and also decision making comes under this flow control. Now let's move these classes to this package. Just select this, copy and paste. Now you can see here our decision making and loop is inside flow control. Now I will remove these classes here. Now you can see all our flow control classes are grouped together. Now I will create a sub package inside this package. Flow control dot loop and click finish. Now here a sub package has been created. Now I will move this loop into that package. Now you can see here the package name. So the package statements is always the first line and it must be written at the top. After the package, if we have any import statements, that will be here. Suppose let's import scanner class. Now you can see the import statement. So the order will be package, import statements and class. Now let's connect with types of packages. First, user-defined packages. What we created just now is called user-defined packages. com.spell.flowcontrol.loop and com.spell.flowcontrol. These are created by us. So these are called user-defined packages. Now let's see built-in packages. When we used scanner, this is coming from Java util.scanner. So this is called built-in package. Built-in packages gives us ready-made classes, so which we can directly use. Now one more important concept. What should we keep inside a package? A package should contain related classes like flow control. Here we have flow control, decision making, and inside that we have sub package flow control.loop and loop. So it represents a feature or a functionality. This makes your project easy to understand, easy to maintain, and easy to scale. One package equal to one responsibility. Now let's create a separate packages and move these classes into that. Keep only data type related classes in this package. Click on source, create new package. Here we have literal. So com.spell.literal. Click finish. Just select this literal Java file and move into this package. And also we have operators. Again create new package. com.spell.operator. Now I will move this operated Java file into this com.spell operator package. And now here we have varargs and variables. Create for this also. And move this variable.java file into this package. Now you can see how neat it is. Everything is inside the packages what they meant for. Here flow control and here flow control.loop. It contains only loop related class, and for literal. So everything is organized. Now let's see some of the common mistakes. While creating the package name, The package name should be meaningful. We should not keep names like test, ABC, or demo. These names don't tell what the package contains. So if I keep com dot, spell dot, some ABC, it is nothing. We don't know what's inside that, what it is doing, what functionality it contains. So always use meaningful names while creating packages. And next, not following the naming conventions. Writing package names in uppercase. While creating package names, we should not use uppercase. Always use lowercase. This is not valid. Next, missing unrelated classes. Like putting all classes in one package, like what we did earlier. We kept all our classes in data type package. Now we have organized clearly so it can understand what it contains. So when you avoid these mistakes, your code becomes clean and easy to understand. Clean name and proper structure make code professional. So this is the end of code part. Before ending this video, I have a small task for you. Take your existing classes, create a package, create a sub-package, organize your classes properly. Also try this. Change package names and observe how folder structure changes. This will give you better understanding. Practice organizing your code. So that's all for today. In the next video, we will understand about class level modifiers in Java and understand how access work. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about class level modifiers in Java. We will understand what are modifiers, types of class level modifiers, why they are important, real world use and common mistakes. Let's get started. In the previous video, we learned about packages. We saw how to organize classes into different packages. Now here is one question. Can we access every classes from anywhere? Or can we control who can use our class? Now think about this. When you enter an office building, you don't just walk in anywhere. There are security gates. Sometimes you need an ID card to enter certain areas. Some areas are open for everyone and some are restricted. Same way in Java, not every class should be accessible everywhere. We need control who can access what. What are modifiers? Modifiers are keywords used to control visibility and access of classes and members. In this video, we will focus on class level modifiers. Modifiers define who can access your class. In Java, we have two class level modifiers, public, default. Let's understand each one. Public class. This class can be accessed from anywhere from any package. Default class. This class can be accessed only within the same package. So the difference is public is accessible everywhere. Default is accessible within the package. So public is open, default is limited. Now let's see this practically. Why modifiers are important? Modifiers are important because they control access, improve security, help in proper design. Control access to protect your code. Now I will create a new package so that we can organize our code properly. Here, click on this and select new and select package. I will give my package name as modifiers. Spell dot modifiers and click finish. Now you can see our modifiers package has been created. Now in Java we have two types of class level modifiers, public and default. Now I will create separate classes for each one so that we can understand easily. Click on this, select new and select class. I will create my class name as public modifier example. Click on main method and finish. You can see our public modifier example has been created. Now I will create another class default modifier example. Check on this main method and click finish. Now our two classes has been created, but here you can see it is showing the public keyword. I will remove this. Now this will become default class. Now here we have two classes, public modifier example and default modifier example, which is default. Names itself clearly tells what modifier we are using. Both classes are in the same package. So inside this package, we can access both. Let me show you that. Here, inside this main method, I will create object for default modifier example. Just type default and press Ctrl space. It shows you the suggestions. Click on this and press enter and give a identifier. So since we are creating object, I will use new keyword. Now here I will write a print statement. Now here I will use a print statement. Now I will run this program. Now you can see the output access modifier. Repeat. Now you can see the output access default modifier. Here I am inside public modifier example and I am creating object for default modifier example. No error. Why? Because both classes are in the same package. Default modifier allows access within the package. Now let's move to another package and see what happens. Now I will go to this operator package. Here now I will try to access the default modifier example class. Here we cannot see the suggestions also. Let's try to copy and paste here. Here now we are accessing the default modifier example. Immediately you see an error. It shows to create a class default modifier example. Why? Because default means it is accessible only inside the own package. Outside the package we cannot access it. Now let's make a small change. I will change default modifier example from default to public. Now observe carefully. Here you can see the import statement. When I click this, the error is gone. So what did we learn? Public class can be accessed from anywhere. Default class is restricted to its own package. Public is accessible everywhere. Default says inside the package. So this is the end of code part. Now let's look at some common mistakes. Trying to access default class from another package. Using public for every classes. Better approach, use public only when needed. Use default for internal classes. Use modifiers wisely. Before ending this video, I have a small task for you. Create two classes, one public, one default. Try accessing them from other package and observe the behavior. Practice access control to understand better. So that's all for today. In the next video, we will learn about member level modifiers in Java and understand access in detail. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn about member level modifiers in Java. We will understand what are member level modifiers, types of modifiers, why they are important, real world use and common mistakes. Let's get started. In the previous video, we learned about class level modifiers. We saw how to control access to classes. Now think about this. Inside an office building, there are different rooms. Some rooms are open for everyone, some are restricted, and some are completely private. Same way in Java, inside a class, we have variables and methods, and we need control who can access them. That is where member level modifiers come into the picture. Member level modifiers control access inside the class. What are member level modifiers? Member level modifiers are used to control access variables and methods inside a class. In Java, we have four main modifiers: public, private, protected, default. Modifiers control who can access your variables and methods. Types of member level modifiers. Now let's understand each one. I will explain in a very simple way. First, public. Public means you can use it from anywhere, from any class, from any package. It is open for everyone. Next, private. Private means it is only inside the same class. No other class can use it. It is completely restricted. Next, protected. Protected means it works inside the same package and also in child classes, even in another package. Next, default. Default means it works only inside the same package. Outside the package, we cannot use it. So, if you look at it simply, public is open for everyone, protected works inside the same package and also in child classes. Default works only inside the package and private works only inside the classes. Access becomes more limited from public to private. Now let's understand where we use this in real world. Imagine a banking application. Account balance should not be accessed directly, so we keep it private. And we provide methods to access it safely like deposit, withdraw. Some methods can be accessed inside package only, some can be used anywhere based on requirement. So modifiers helps us control access, protect data and design better applications. Modifiers helps us protect and control our data. Now let's understand this with code. Now let's see member level modifiers. Now same in this modifier package, I will create a new class. And check on the main method and click finish. Now our member level modifier class has been created. Now first we will work with variables, then next we work with methods. Same concept, two places. Now inside this class I will create different access modifiers variables. So these are different access variables: public, private, protected and default. Now I will create a method display. And now I will print these variables. Now inside this main method, I will create an object for member level modifier and call this display method. Now let's run this program. You can see the output 10, 20, 30 and 40. Here display is printing all variables: public, private, protected and default. So and everything is working. Why all are accessible? because we are inside the same class. Inside the class, no restriction. Everything is accessible. Now we understood same class behavior. Next, let's move to another class in the same package. Now I will go here in public modifier example and I will try to create object for member level modifier and try to access the variables. Now from this member object, I will try to print all the variables. Now here you can see public variable is working and protected variable is also working and default variable is also working, but we cannot access private variable. Why? Why private variable is not working? Because private works only inside its own class. So in same package, public accessible, protected accessible, default accessible and private is not accessible. Now I will run this program. Now you can see the output 10, 30 and 40. So private stays inside class when others can move within the package. Now we completed variables. Next, let's move to the methods. Same rules, same behavior. Now here in this member level modifier class, I will try to create methods with different access modifiers. Now you can see I have created different access modifiers methods. This is public and this is private and this one is protected. And next this one is default. Now we will try to access these methods in the same class. Now I will run this program. Now you can see the output: public method, private method, protected, default. Now again I will run this program. Now you can see public method, private, protected and default. So within the package, within the same class, we can call all methods public, private, protected, default, everything works. Inside the class, methods also have no restrictions. Now same step again. Let's move to another class in the same package and let's see how these methods access. I will go to same public modifier example class. Now here I will try to access the methods from member level modified class. Now let's try to access the member level modified methods in the different class of same package. Now you can see the error private method we cannot access because this belongs to member level modifier. So we can access only inside this class. So from another class, public method will work, protected method will work, default method will work, but private method will not work because private method works only inside the class. So same rules apply for variables and methods. Same access rules apply for variables and methods. Now let's understand different package behavior. If classes are in different packages, public will work. Protected works only if there is inheritance. And default will not work. Private will also not work. So inside the package, Only public is fully accessible. Remaining modifiers have restrictions. Outside the package, public works. Others get restricted. So, this is the end of code part. Why modifiers are important? Modifiers are important because they control access, improve security, protect data. Proper access control improves code quality. Some of common mistakes. Using public everywhere, not using private for variables, confusing protected and default. Better approach, use private for variables and control access using methods. Use private to protect your data. Before ending this video, I have a small task for you. Create a class and variables and methods with all modifiers. Try accessing them from same package and different package. Observe the behavior. Practice access levels to master modifiers. So that's all for today. In the next video, we will start Java OOP concepts. This is the heart of Java programming. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to SP Learning Labs Java programming course. In today's video, we are going to start Java OOP concepts. This is a core concept, so focus carefully and try to understand clearly. Because OOP is the heart of Java programming. Once you understand this, everything in Java becomes much easier. We will understand what is OOP, why we use it, real world understanding, and how it helps in building applications. Let's get started. Recap. In the previous videos, we learned Java basics like variables, conditions, and loops. We also learned modifiers, how to access, how to control access, who can use our variables, and methods like public, private, protected. Those programs were small and easy to manage. But now think about this. What if we build a big application like banking system or shopping app? If we write everything in one place, it becomes messy, hard to understand, hard to maintain. It is just like building a city without any planning. Imagine buildings here and there, roads not connected properly, no clear structure. Everything feels confusing. Without proper structure, everything becomes messy. So, we need a better way to design programs. That is where OOP comes into picture. What is OOP? OOP stands for Object Oriented Programming. Simple meaning, it is a way of writing programs using objects. These objects represent real world things or real world entities like car, student, bank account. And each object has two things: data, what it has, behavior, what it does. For example, a bank account has balance and it can deposit or withdraw. OOP combines data and behavior into one unit. Real world understanding. Now let's understand this with a simple example. Think about a car. You already know a car has some data like color, speed, model, and at the same time it also has behavior like start, stop, accelerate. Now here is the interesting part. Instead of keeping all this separately, we put everything together in one place. All the data and all the actions. So anything related to the car is inside one object. Easy to manage, easy to understand. And that is exactly how OOP works. In our daily life, related things are always together. OOP follows the same idea. Why OOP is important? First, reusability. We can reuse code. Second, maintainability, easy to update and fix. Third, scalability, easy to build large applications. Fourth, structure, code becomes clean and organized. In this OOP journey, we will learn step by step class and object and also constructors, encapsulation, inheritance, polymorphism, abstraction. We will understand everything in a simple and clear way. So that's all for today. In the next video, we will start with class, object and constructor. This is where everything begins. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn class and object in Java. These are very important concepts because everything in OOP starts with class and object. Let's get started. In the previous video, we learned about OOP. We understood how OOP helps us organize code properly. Now think about this. If OOP is about objects, then how do we create them? Where do they come from? Just like before building a house, we don't start randomly. First, we need a proper plan, a blueprint. It tells us how many rooms, where the doors go, and how everything should look. Without that plan, we can't build properly. Everything becomes confusing. So before creating objects, we need a blueprint. What is class? In Java, we call that blueprint a class. So what is a class? A class is a blueprint of an object. It defines what data an object will have and what actions it can perform. For example, let's take a car class. It can have variables like color, speed, and it can also have methods like start, stop. So in simple words, a class contains variables and methods. Variables represents data and methods represent actions. Class is just a design and not an real object. What is object? Now let's understand object. This is very simple. Object is a real instance of a class. Simple meaning, object is a real thing created using a class. In simple words, object is something you can actually see or use. Also remember this, an object has two things: state, what it has; behavior, what it does. But imagine your car, it is with some color and moving at 100 speed. That real car is an object. That car has state like color and speed and behavior like start and stop. So class is just a design, but object is the real thing which we actually use. And in Java, everything is based on objects. We create objects, we use objects, we work with objects every day. Object is the real thing, class is just the plan. Now let's understand this with code. Now let's create a new package. Since we are writing code for OOPS concepts, I will create package name as OOP concepts. And click finish. Now our new package has been created. Inside this, now I will create a class named car. And remember, class name should start with a capital letter. So I am following naming conventions and click finish. Now our car class has been created. Now inside this class, I will create two variables. These are variables: color to store color of the car and speed to store speed. So this is the data of object. Now this is a method start. Now inside this method I will print a statement with the message so this is a method start an action performed by the car. It prints car is starting when we call this start method. So this is our class. So it contains variables and methods. Now we need a main method to run the program. Just I will type main and use shortcut control plus spacebar and press enter. Now our main method has been created. Now inside this main method we will call so this is the entry point of the program. Execution starts from here. Now inside this method I will create a object for car. Here car is the class name and car is the reference identifier. Now new creates the object and this is constructor. Now I will set values for our variables. Car dot color equals to red and car dot speed equal to 100. So now I have assigned values for color and speed. So now object has data. Now let's call the method. Now this will execute the start method and prints the message car is starting. Now let's run this. Now you can see the output in the console, car is starting. So finally we created a class car and we created an object and we assigned data and we used behavior. So first we design, then we create, then we use. So that's all about code related to class and objects. Why it is important? Class gives structure, object stores real data and helps us use that data. Without classes and objects, OOP cannot exist. Common mistakes. Now let's see some common mistakes. Thinking class and object are same. They are not. Class is just a blueprint, object is the real thing. Another mistake, forgetting to create object. Without object, we cannot use variables and methods. And also using unclear or random class names. That makes code hard to understand. Class is design, object is the real usage. Best practices. Some best practices are keep class names meaningful. For example, car, student, bank account, not A, B or test. Follow naming conventions. Class names use Pascal case like car, bank account, and method names use camel case like start car, calculate speed. Keep your class simple, only include related variables and method. Don't add unnecessary things. Write clear, clean and meaningful classes. Homework and questions. Before ending this video, I have a small task for you. Create a class, for example student. Add variables like name, age and add methods like display details. Now create an object, assign values, call the method and observe the output. Try creating multiple objects, view different values and see how object behaves. Also try with another classes like car or bank account. Practice creating classes and objects to build strong basics. Now let's see questions. What is a class? What is an object? Difference between class and object. Can we use class without creating object? How many objects can we create from one class? What is the role of new keyword? If you understand class and objects clearly, OOP becomes easy. So that's all for today. In this video, we learned class and object. In the next video, we will learn about constructors. Now we know how to create objects. Next, we will learn how to initialize them. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn constructors in Java. This is very important concept. We will understand what is a constructor, why it is used, different types of constructors and common mistakes. Constructors helps us initialize objects automatically. Let's get started. In the previous video, we learned about class and object. We created objects and assigned values manually. But here is a question. Every time we create an object, should we assign values manually? Is there a better way to set values automatically? Now think about this. When you buy a new phone, the moment you switch it on, it already has some default setup like language, time and basic settings. You did not set everything manually, it is already initialized. Things are ready the moment you start using them. So what is constructor? Same concept in Java. When we create an object, we want that object to have some values right from the beginning. Instead of setting values manually, we can do it automatically using a constructor. So a constructor is a special method used to initialize an object by setting its values. It has same name as class and it does not have any return type, not even void, and it runs automatically when object is created. Constructor has no return type and runs automatically when object is created. Types of constructors. In Java, we mainly have two types of constructors, default constructor and parameterized constructor. First, default constructor. A default constructor does not have any parameters, That means we are not passing any values, so object is created with default setup. Next, parameterized constructor. A parameters constructor takes parameters. Parameters means variables used to receive values. In simple words, we pass values while creating object and those values are stored using variables. So, objects get values immediately at the time of creation. Parameters are variables that takes values during object creation. Now let's understand this with code. Now let's create a sub package under this com.spell.oops concepts. Now I will give this as dot constructors and click finish. Now inside this constructor I will create a class and I will name this class as student. Follow the naming conventions. Now I will check the main method and click finish. Now you can see our student class has been created. Now inside this class I will create two variables, name and age. So these are variables. Name stores student name and age stores student age. This is the data of object. Now let's try to create default constructor. This is called default constructor, same name as class name with no parameters. So it runs automatically when object is created and it prints default constructor called. Now let's look into parameterized constructor. This is parameterized constructor. It takes parameters. N receives name and A receives age. Then we assign values, name equal to N and age equal to A. So object get values at the time of creation. Now let's create a display method. This is our display method. When we call this, it prints name and age. Now inside this main method, let's create object for student. Now observe carefully. We are creating object for student and this one is the reference which is an identifier student. We are creating object for student. So the moment object is created, default constructor is called automatically because of this. So output will be default constructor called. Now let's create another object for student. And here I will type student 1. Now we have created another object for student. This time we pass values. So here we pass Ravi and age 22. So object is created with values already set. Now after this, let's call display method. So now we call display method. It will print Ravi and with age 22. Now let's run this. So overall what happens? First object is created. Constructor runs automatically and this default constructor called. Next, second object is created and parameterized constructor set values with Ravi, name and age 22. After that, we call display method and use the object. So object is created, constructor runs, values are set, then we use it. Now we understood how constructor work, but one important question is when actually constructor is called. When exactly constructor is called and before object creation or after object creation or at the same time. Let's see this clearly. I will add some more print statements so we can observe the exact execution order. Here for default constructor already we have added an print statement. Now inside this parameterized constructor I will add another print statement. Now here in the main method at the starting I will write here creating first object. And after this I will use another print statement. and I will write first object created. Now here also I will use another print statement and write creating second object. Now after this, I will use another print statement with second object created. Now observe carefully. First it prints creating first object. Then this line calls student, this object will be start creating, and immediately constructor is called, and so output will be default constructor called. Repeat. Now observe carefully. First it prints creating first object. Then this line runs. Here object is created. Immediately constructor is called. So the output will be default constructor called. Then it prints first object created. Next it will print creating second object. Now the object is created, immediately parameterized constructor is called, so output will be parameterized constructor called, and values are assigned. Then it prints second object created. Now let's see this by running the program. Output exactly what we have discussed. First it printed creating first object, then default constructor called, after that first object created, next creating second object, and also parameterized constructor called, and after that second object created. So clearly we can understand the moment object is created, constructor runs automatically. We don't call constructor manually. So object creation and constructor execution happens together. So this is the code part related to constructors. Why it is important? Why constructors are important? Because they initialize objects, reduce manual work, improve code clarity. Constructor makes object creation easy and clean. Common mistakes. Some common mistakes are: first, thinking constructor is just a normal method. It is not. Constructors runs automatically. Methods need to be called. Next mistake, giving return type to constructor. Remember, constructor should not have any return type, not even void. Another mistake, constructor name not matching class name. It must be exactly same including uppercase and lowercase. And one more, expecting constructor to behave like a method, but constructor is only for initialization. So constructor is not a method, it is for initialization. Best practices. Some best practices are: always use constructor to initialize values instead of assigning values later. Keep constructors simple, only initialize values, don't write complex logic inside. Use meaningful parameter names like age, name. If needed, use multiple constructors to handle different scenarios. So use constructors to prepare objects properly. Before ending this video, I have a small task for you. Create a class and add both constructors. Create objects and observe the behavior. Now try this important practice. Add some system.out.statements and observe the execution order. Which runs first, object creation or constructor? Now try this. Remove parameterized constructor, then create object with values. Observe what happens. Does it work or give error? One more, don't write any constructor, just create object. Observe carefully. Will Java create a default constructor automatically? Now let's see questions. What is constructor? Difference between method and constructor. Types of constructors. Can constructor have return type? When is constructor called? What happens if no constructor is defined? Practice different scenarios to truly understand constructors. So that's all for today. In this video, we learned constructors in Java, how to initialize objects, and how constructors work. In the next video, we will learn encapsulation and data hiding and understand it clearly step by step. Now we know how to create and initialize objects. Next, we will learn how to protect them using encapsulation. If you found this helpful, like, share, and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn encapsulation and data hiding. This is a very important concept. We will understand what is encapsulation, what is data hiding, why they are important, how to implement them, and where we use them in real world applications. Let's get started. In the previous video, we learned about constructors. We created objects and initialized values. Now think about this. In a bank ATM, you can check balance, deposit money, withdraw money, but can you directly access the bank database? No, everything is controlled. You can only access data through proper methods. So data is hidden, access is controlled. What is encapsulation? Same concept in Java. What is encapsulation? Encapsulation means wrapping data and methods together and controlling access to data. In simple words, we hide data and allow access through methods. What is data hiding? Data hiding means restricting direct access to variables using access modifiers like private. So encapsulation is the concept, data hiding is how we achieve it. Encapsulation is the idea, data hiding is the implementation. Now let's understand this with code. Now let's create another subpackage under OOP concepts. I will create a subpackage encapsulation. And click finish. Now inside this, I will create a class bank account. And check the main method and click finish. So this is our bank account class. Now inside this class, I will create a variable. And also I will write two methods. Now observe carefully what I have written. Here balance is private access modifier. This is called data hiding. So because we are restricting direct access to the variable, we cannot access it directly from outside the class. Now look at the full class. We have data balance and methods set balance and get balance. So both. Now look at the full class. We have data balance and methods set balance and get balance. Both are combined together. This is called encapsulation. So remember, private variable is data hiding and data plus methods is encapsulation. Now look at the setter. Here for this set balance, I have written double amount as parameter and balance equal to amount. So balance is class variable. So this works fine. What if parameter name and variable name are same? Let's see this. Now you can see here one suggestion is coming. The assignment to variable balance has no effect. Why this? Because both are same. Java gets confused. This will not work correctly. Now what we will do, here I will type this dot balance. Now you can see that suggestion is gone. This refers to current object. So we clearly tell Java assign parameter value to the class variable. Now how do we use this? This setter and getter methods. Setter use it to set value, getter use it to read value. Before encapsulation, we used to write balance equal to 1000 and directly anyone could change it from anywhere, which is not safe. But now we use setter to set the balance and getter to get the values. So we can control how values are set and how safely access the value. Let's see it. Now I will create object for this bank account. Now I will set the balance. So now 1000 value is stored inside balance. Now I will get the balance. I will print it in print statement. Now I will run this program. Now you can see the output 1000. So, and this is exactly how encapsulation works. And notice we never accessed balance directly. We used method, setters and getters. So data is protected. We hide the data and control how it is used. In real projects, we don't write getters and setters manually. Imagine this. What if your class has 20 variables or 30 variables like name, age, email, phone, address, and many more. Now in this class we have one variable and we manually return set balance and get balance. For each variable you need to write setters and getters. That means 20 variables, 40 methods. This is a lot of code to write. So writing all this manually takes time and increases chances of mistakes. So in real projects we use IDE support. Eclipse provides an option to generate setters and getters automatically. Now let's see this. Now I will create some variables. Now imagine this writing setters and getters for this variable. It will take a lot of time. Now what I will do, I will just press right click and here you can see the option source, and after this you can see options generate, getters and setters. Just click this. Now here you can see our variables. Here you can see the option select all, and just you can also select the access modifiers. Now I will click generate. Now you can see for all the variables setters and getters has been created automatically. So don't write repetitive code. Let tools do it for you. Now you might have a doubt. In previous video we used constructors to initialize values, but here we are using setter method. So what is the difference? So constructor is used to set values at the time of object creation. Setter methods is used to set or update values after object is created. Let me show you clearly. If we use constructor, value is set immediately. Now it is showing error. Why? Because it does not have any parameterized constructor. Let's create a parameterized constructor. Again go to source. Here you can see generate constructor using fields. Now you can see this and click generate. Since here we are passing only balance. Now what I will do, repeat. Here you can see the error. Why? Because we don't have any parameterized constructor. Let's create one. Now you can see the error is gone. Now here I will print a statement. And now here I will change to 1500. Now let's run this. You can see here first it has printed 1000 after object and after 1500. So what happened here? Now let's see what happened. First we passed value to constructor parameterized constructor. So what happened here? When we passed the value through parameterized constructor, it sets immediately, and after that when we used set balance, the value is changed. So the output is 1500. So you can see value is updated after object creation. So both are used to set values, but constructor sets initial value and setters updates value anytime. So in encapsulation, we mainly use setter and getter to control access. Constructor set once, setters can update anytime. So that's all about encapsulation coding part. Why it is important? Why is encapsulation important? It protects data, prevents misuse, improves security, and makes code clean and maintainable. Encapsulation keeps data safe and code clean. Common mistakes. Some common mistakes are making variables public. This breaks data hiding. Accessing variables directly instead of using methods. Not using proper getters and setters. Never expose your data directly. Best practices. Some best practices are always keeps variables private. Use getters and setters. Protect first, then provide controlled access. Homework and questions. Create a class, add private variables, add getter and setter methods. Try accessing variables directly and observe the error. Also try this. Use Eclipse option, right click, generate getters and setters and see how it automatically creates methods. Most asked questions. What is encapsulation? What is data hiding? Difference between both? Why use private variables? Now it's your turn. Try this code yourself. Share your answers in the comment section. If you have any doubts, drop them below. I will help you. Practice manually and then use tools smartly. So that's all for today. In the next video, we will learn inheritance. Now we can protect data. Next, we will learn how to reuse it. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn inheritance in Java. This is very important concept. We will understand what is inheritance, is a relationship, types of inheritance, why multiple inheritance is not supported, and complete code explanation. Let's get started. In the previous video, we learned about encapsulation, how to protect data. Now think about real life. A child gets features from parents like height, habits, behavior. Child does not create everything again. It reuses from parent. Features are passed from parent to child. What is inheritance? Same concept in Java. Inheritance means one class gets properties and methods from another class. Parent class to superclass, child class to subclass, just like parent to child. Inheritance reuse existing code. Is a relationship. Now this is very important, pay attention. Let's understand is a relationship in a simple way. Dog is a animal. Student is a person. Manager is a employee. Now don't just listen, actually think. If I say dog is an animal, does it sound correct? Yes, it makes sense. That means we can use inheritance here. But what if I say car is a driver? That sounds wrong. So we should not use inheritance here. If it sounds natural, inheritance is correct. If it sounds wrong, stop right there. Okay, now that we understand is a relationship, next question is, are there different types of inheritance? Yes, we have different types. Single inheritance, multi-level inheritance, hierarchical inheritance and multiple inheritance. We will understand everything step by step, and the best way to learn this is by writing code. So now we are moving to the coding part. We will take each type one by one and understand clearly. Now let's create another sub-package under OOP concepts. I will keep the name as inheritance and click finish. Now inside this package, I will create a new class person and click finish. Now inside this person class, I will create two methods. So this is our person class. Observe carefully. This is our parent class person. It has two methods, void eat and void sleep. Now I want to create another class student, and student is also a person, right? So instead of writing again, we reuse it. Let's create first student class. Now for that, to reuse, we use the keyword extends. Person. Very important, if you want to use another class features, we must use extends keyword. Now inside this student class, I will create another method study. I will print a statement student studies. Now see this carefully. Student extends person. That means student is inheriting person. So it can use eat method and sleep method from person and plus its own method study. Now let's write the main method and run it. Now here I will create object for student. Now I will call the methods eat, sleep. And also study. Now let's understand this. First, we created object for student. This creates the object. Next, we called student.eat method. This method is not in the student. It comes from person. So the output will be person eats. Next, we called student.sleep method. Again, it is coming from person. So the output will be person sleeps. Next, we called student.study. So this is inside the student class. So the output will be student studies. Now let's run this and see the output. Now you can see the output person eats, person sleeps and student studies. Even though we created student object, it's still able to call parent methods. This is the power of inheritance. So here clearly child class is using parent class features without rewriting. Reuse without rewrite. So this is single level inheritance code example. Now inside this method, I will print a statement father drops at school. Now I will create another class mother. And click finish. Now here also I will use the same method. So what we have done, now both parents have same method drop at school. Now let's see what we have done. Now both parents have the same method drop at school. Now let's try to create a child class and extend both father and mother. Now here I will use extends keyword and father also mother. Now immediately you can see the error here, syntax error. Java does not allow this. You cannot extend multiple classes. Now think carefully. If Java allowed this, and let's create an object for child. Now what I will do, I will create object for child Here, observe carefully. Now I am calling c dot drop at school. Then what should happen? Should it print father drops at school or mother drops at school? Java gets confused. It does not know which method to choose. This confusion is called diamond problem. So to avoid this confusion, Java simply says no multiple inheritance with classes. If I remove this, the error is gone. So remember, one class can extend only one class. If there is confusion, Java says no. So this is why Java does not support multiple inheritance. Now let's move to the next type, hierarchical inheritance. Simple meaning, one parent, multiple children. Think like real life. One parent can have multiple children. Same concept here. Now inside this person class, I will create another method. Void work. And I will write person works. Now what I will do, I will create another class teacher. And click finish. Now inside this teacher, first we will extend the person class. And now inside this teacher, I will write a method void teach. And now I will use print statement. Now again I will use another class doctor. And click finish. Now here I will extend the same person class. Now inside this doctor class, I will write another method treat. I will print a statement doctor treats. So what we have done here? First, this is our parent class person. We have written void work method. And next, what we have done, teacher. Here we extended the person class. So teacher is the child class and person is the parent. And again we extended the same person class and this is also child. So both are extending person. So both can use work method. Now let's write the main method. Now I will create object for both teacher and doctor. Now let's see what we have done. First, we have created teacher object and call teacher.work and teacher.teach. Here, teacher.work comes from person class and teacher.teach comes from its own class, and it will print output as teacher teaches and also person works. Here we also created object for doctor and called doctor.work method and doctor.treat method. So this comes from parent class person. So this also will print person works and doctor treats. Now let's run this and see the output. Now you can see the output: person works, teacher teaches, and person works, doctor treats. So what is happening here? One parent is shared by multiple children, and each child can use parent features plus its own features. One parent, many children, shared features. So this is about hierarchical inheritance. Now let's create another class. I will keep the class name as animal and click finish. Now inside this animal method, I will write eat method. Finish. Now what I will do, I will extend animal class here. Now inside this class, I will write a method bark. And I will print a statement dog barks. Now again I will create another class. This time I will name this class as puppy and click finish. Now this class extends dog class. Now inside this puppy class, I will write a method weep. And I will print a statement puppy weeps. Now look at what we have done. First, animal. This is the parent class. Next, dog class. This is the child of animal. And after that, we have created puppy class. So this is the child of dog. So this is like a chain. Animal to dog and dog to puppy. Now important point, puppy is getting features not only from dog but also from animal. That means eat method from animal, bark method from dog, and weep from its own. Now let's write the main method and see the output. Now I will create object for puppy. Now what we will do, we will call the methods. Now let's understand this. First we created object for puppy and then we called puppy.eat method. This comes from animal and output will be animal eats. And next we are calling puppy.bark. This comes from dog class. So and the output will be dog barks. And next we are calling puppy.weep method. This comes from its own class. Now let's run the program and see the output. Now you can see the output: animal eats, dog barks, and puppy weeps. So what is happening here? Features are passing level by level, animal to dog and dog to puppy. That is why we call it multi-level inheritance. One chain, multiple levels, full reuse. So this is about multi-level inheritance code example. Common mistakes. Now let's quickly look at some common mistakes. One common mistake is trying to access private variables. Remember, private members cannot be accessed directly, even in child class. Another mistake is forgetting to use extend keyword. If you don't write extend keyword, then inheritance will not happen. And get the basics right, everything else become easy. Best practices. Now let's talk about some best practices. First, always check, is a relationship. If it does not feel natural, don't use inheritance. Next, keep parent class simple and general. Don't make it too specific. And child class should be more specific. It should not add its own behavior. Keep parent simple and make child powerful. Homework and questions. Before we wrap up, here is a small challenge for you. Create a class person, add a method walk, then create employee, extend it from person, and add work method. Next, create manager class, extend it from employee class, and add manage method in employee class. Now create object of manager and call all methods. Observe carefully how everything is connected. Now let's make it more interesting. Try this variation. Create object for manager class and make reference to person class. And same again create object for manager class and point reference to employee class. Now try calling methods, watch closely which methods are accessible and which are not. This is where you understand it clearly. This small experiment will give you real clarity, not just theory but actual understanding of how inheritance behaves. Most asked questions. What exactly is inheritance? What is a relationship? Why Java does not support multiple inheritance? How many types of inheritance exist? Don't just watch, try it yourself. Comment your output and what worked, what did not. If something feels confusing, drop your doubt below. I will help you to clear it. Try different references, that's where real learning actually begins. So that's all for today. In the next video, we will learn about polymorphism, overloading and overriding. This is very important concept to understand in VOOP. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. polymorphism, overloading, overriding, and super keyword. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn polymorphism, overloading, overriding, and super keyword. This is one of the most important concepts in object-oriented programming. So focus carefully and understand step by step. Let's get started. In the previous video, we learned about inheritance. We saw how a child class can use features from a parent class without writing the same code again. So basically, we learned how to reuse code. Now the question is, can the same object behave differently? Let's take a simple real life situation. Think about yourself. At home, you behave one way. At office, you behave another way. With friends, completely different. So what is happening here? Same person but different behavior based on situation. That is exactly what polymorphism means. One thing, many behaviors. What is polymorphism? Poly means many. Morph means forms. Polymorphism means one thing can have many forms. In simple words, same method name, different behavior. Types. Now let's understand the types of polymorphism. There are two types. Compile time polymorphism, which is method overloading, and runtime polymorphism, which is method overriding. As we go through the code, everything will become clear. So now let's move to the coding part. We will go step by step. First we will understand overloading, then we will move to overriding, and finally we will see super keyword. Observe carefully, this is where everything becomes clear. First, let's understand method overloading. Same method name but parameters are different. I will create another package under whoop concepts. I will keep the package name as polymorphism. And click finish. Now inside this I will create a new class. Calculator. And click finish. Now inside this class I will create some methods. And here for this add method I will pass two parameters. Next I will create another method. For this I will pass three parameters. And I will return a plus b plus c. Next I will create another method. Now observe carefully. Here method names are same, add, add and add. But what is changing? Number of parameters. For this method we are passing 2 parameters, and for this add method we are passing 3 parameters, and again for this add method we are passing 2 parameters. So that is why Java treats them as different methods. One important point, return time can also be different. Here you can see we are using double. So this will return double. Like here it is int and here it is double. But only changing return type is not enough. Parameters must repeat. But only changing return type is not enough. Parameters must be different. Now let's use this and run. Repeat. Now let's use this calculator class and run the program. Here I will create a new class. I will keep the class name as method overloading. And I will check the main method and click finish. Now what I will do, I will create object for calculator. So this is how we create object. Now what I will do, I will call the methods we created in calculator. First I will pass 2 parameters. Here I will pass 10, 20. Next I will pass, repeat. Now next I will use another method. Now this time I will pass 3 parameters. Here I will pass 10, 20, 30 as parameters. Now I will call again last method, which is double. Here I will pass 10.5 and 20.5. Now understand what is happening. Java looks at the input. First it will see 10, 20. So it is int method. Next we will pass 3 parameters and it identifies as it is passing 3 parameters to method. And next we are passing double parameters. So we will run this and see the output. And one more thing, and this decision happens before program runs during compilation. That is why method overloading is called compile time polymorphism. Now you can see the output 30, 60 and 31.0. So based on input, correct method is selected. So this is about method overloading. Let's see an error. Suppose now what I will do, here instead of double I will pass int. You can see the error immediately. Because parameters are same, Java cannot decide which method to call. So it stops at compile time itself. So remember clearly, same method name, parameters must be different. Decision happens at compile time. Same method chosen before execution. Now let's move to method overriding. This works with inheritance. What I will do, I will create a class animal and click finish. Now inside this, I will create a method void sound. And inside this method, I will print a statement animal sound. Now what I will do, I will create another class dog. And click finish. Now, repeat. Now what I will do, I will create another class dog. And click finish. Now this class will extend animal. Now inside this Now inside this dog class, I will create same method void sound. Now here what I will write, I will print a statement as dog barks. So observe carefully. Method name is same, sound. Parameters are same. Here we are not passing any parameters. Return type is also same, void. But behavior is changed. So what is happening here? Child class is giving new implementation. It is replacing parent behavior. Here we have printed dog box. So we are changing the behavior. Now let's create a main class and run this. I will create a new class method overriding. And check on the main method and click finish. Now here I will create object for dog. And I will keep the reference to animal. and call the sound method. Now think carefully. Here object is dog and reference is animal. Which method will run? Dog method, and the output will be dog box. Java, repeat. Here one important point. Java did not decide this at compile time because reference is animal. It decides at runtime based on actual object. That is why method overloading, repeat. That is why method overriding is called runtime polymorphism. Now let's run this program and see the output. You can see the output dog box. So this is called runtime polymorphism. Now let's prove this. Now what I will do, here instead of dog I will keep animal. And here the method is same in the animal also. Now I will run this program. Now you can see the output changed animal sound. So when we change object animal, the output is changed to animal sound. Same reference type but different object, output changes. That proves decision is happening at runtime. So remember rules. Method name must be same, parameters must be same, return type must be same. Decisions happen at runtime based on object type. So this is about method overriding. Common mistakes. Now let's look at some common mistakes. First mistake, changing only return type. Method name and parameters are same, only return type is different. This will give error because Java cannot identify methods using return type alone. Next mistake, method signature not matching. In overriding, method name parameters must be exactly same. Another common mistake is forgetting inheritance. Overriding works only when child extends parent. Match everything, then override works. Best practices. Now let's see some best practices. Use overloading when you want, repeat. Use overloading when you want same operation with different inputs. Use overriding when you want to change behavior of parent method. Keep method names meaningful so it's easy to understand what each method does. Same name for similar work, change behavior when needed. Summary, homework and questions. Now let's do a quick revision. Method overriding. Same method name, parameters are different, return types can be same or different. Decision happens at compile time. Method overriding. Same method name, same parameters, same return type, but behavior changes. In child class, decision happens at runtime. Super keyboard. Used to call parent class method. Super dot method name. Parent runs first, then child runs. Now your task. Create class vehicle, add method start. Create class car and bike, override start method. Inside child class, use super.start and add your own message. Now create objects like this. Create object car and refer the reference to vehicle class. And also create bike object and make reference to vehicle class. call start method. Observe carefully how output changes based on object type. Here you will understand clearly. Most asked questions. What is polymorphism? Difference between overloading and overriding. Why overloading is compile time? Why overriding is runtime? What is super keyword? Try this on your own. Share your output in the comment section. If you have any doubts, ask in the comments. I will help you. Try different combinations, you will understand it better. So that's all for today. In the next video, we will move to abstraction and interface, where we will learn how to hide implementation and focus only on what we needed. This is another very important concept in object-oriented programming. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn abstraction and interface. This is another very important concept in object-oriented programming. So focus carefully and let's understand step by step. Let's get started. So far, we have learned encapsulation, inheritance and polymorphism step by step. Now let's connect this to real life. Think about your mobile phone. You make calls, send messages, use apps, everything works smoothly. But have you ever thought what is happening inside? How the call is connecting, how messages are sent? We don't worry about all that, right? We only use what is needed, all the internal logic is hidden. And that is exactly what abstraction means. We use the features without seeing the complexity. What is abstraction? So what exactly is abstraction? Abstraction means hiding implementation details and showing only functionality. In simple words, you use something without worrying about how it works internally. You just focus on using the feature. So in programming, we show only what is needed and hide all complex logic. Use the feature without seeing the complexity. How to achieve abstraction? Now the next question is, how do we actually achieve abstraction in Java? In Java, we can achieve abstraction in two ways, using abstract classes and interfaces. Now we are moving to the coding part. We will go step by step. First, we will understand abstract class. Then we will move to the interface. Observe carefully. This is where the concept becomes clear. Now let's start with abstract class. Abstract class is a class that can have abstract methods and normal methods. Let me show you. Here I will create a new package under OOP concepts. I will name this one as abstract. Here we are getting error because this is an reserved keyword. And click finish. Now inside this I will create a class animal. Here you can see the option abstract. We will check this one. And click finish. Now inside this class we will create a abstract method. So an abstract class is a class that can have abstract methods and normal methods. I will create an abstract method first. And another method eat. So what is an abstract method? Abstract method means a method without body. It is declared using abstract keyword. It does not have any implementation. It ends with semicolon. Observe carefully. Here we have created sound method. This is abstract method. No body, only declaration. And this eat method, this is a normal method and it has complete implementation. One more important point, we cannot create object for abstract class. For example, if you try to create object for animal, this will give an error because abstract class is incomplete. It contains abstract methods and which don't have implementation. So Java cannot create object. And another important point, abstract method acts like a rule. It tells every child class you must implement this method. Now let's create a child class and see this. I will create a new child class dog and click finish. Now I will extend animal. Now here you observe carefully, this child class dog is showing an error that it must implement the inherited abstract method. So just select the add unimplemented methods. Now the abstract method has been overridden. If you don't override, this one will show error again. Now let's create another class with the main method and run this program. Now here inside this I will create a print statement. And I will create another class. I will name this as and check the main and click finish. Now inside this main method I will create object for dog. And I will refer this to animal. First I will call sound method. And next I will call eat method. Now when I run this, output will be dog barks and animal eats. Let's run this. You can see the output dog barks and animal eats. So what is happening here? We defined a method in abstract class, but implementation is done in child class. This is the implementation. Now, one more important point, abstract class can also have different types of methods. First, abstract methods. No body, only declaration. Child class must implement. Second, concrete methods. This is concrete methods, which is normal methods with full implementation. Child class can use directly. And next, static methods. These methods belongs to the class. So we don't need to create object, we can call directly using class name. Let's create a static method. Now what I will do, now let's run this. Here I am calling the static method directly using the class name. Now let's see the output. Here you can see the output. This is animal class which we have written here. Now let's understand the output. We are calling animal.info. So output will be this is animal class. So remember, static methods belongs to class, not object. Call with class, no object needed. Next we have final methods. These are normal methods, but they cannot be overridden. Child class cannot change them. Let me show you an example. Now, if I try to override this in child class, we will get an error. You can see the error cannot override the final method from animal. Now we will call this method directly in the main method. And let's see the output. Let's print a statement in this. Now again run this main class. Now you can see the output, animal are living beings. So what happening here? Here, when we use a.type calls parent method, output will be animal or living beings. And if we try to override, Java will give error because method is final and it cannot be changed in child class. Final means fixed, no changes allowed. So, abstract class is very powerful. It can define rules and also provide implementation. Define the rule and let child complete it. So, this is the code related to abstract. Now, let's move to interface. Imagine this situation. You are using a car. You press the start button and the car starts. You expect it should start, it should stop, and it should move. Now think about this. Do you see how fuel is flowing inside? How engine is working? No, all that happens internally. You are focusing on what the car should do and not how it is implemented. That is exactly what an interface is. It defines what should happen and leaves how it happens to the class. Interface defines what a class should do but not how it does it. It gives a set of rules and any class that implements it must follow those rules. And one important point, interface provides full abstraction because it focuses only on what should happen and not how it is implemented. That is why interfaces are used to achieve abstraction in a clean and structured way. Now in modern Java, interface can have different types of methods. Now let's look at the different types of methods. Inside an interface, first, abstract methods. These are available from the beginning of Java. They have only declaration, no implementation. So any classes must implement them. Next, default methods. These were introduced in Java 8. These methods already have implementation, so classes can use them directly or override if needed. Then static methods. These are also introduced in Java 8. This belongs to interface and we call them using interface name. And finally, private methods. These were introduced in Java 9. These are used internally inside the interface, mainly to reuse code within other methods. From simple rules to powerful features in modern Java. Now the important question, how do we achieve abstraction? Using interface, very simple. By using implements keyword. A class implements interface and provides implementation for abstract methods. Interface give rules, class give implementation. Now we are moving to the coding part. Let's create an interface and implement it step by step. Observe carefully. Now I will create another new subpackage under OOP concepts, interface. Interface is also a reserved keyword and click finish. Now inside this package I will create a new interface. Click on this and click new. Here you can see the option interface. Select this and I will give the name as vehicle. And click finish. So this is the vehicle interface. Now inside this interface I will create three methods. First I will create abstract method. So this is abstract method. and I will create a default method. So default method we use default keyword, and next I will create a static method. Now observe carefully. This is the start method. This is an abstract method. It has no body, so any class must implement it. Next, fuel type. This is default method. It already has an implementation. So class can use it directly or override if needed. And next, static method info. This is the static method. It belongs to interface, not to object. So we call it using interface name. Now let's create a class and implement this interface. Now here I will create a class car and click finish. Now remember, if we want to use interface, we must use the keyword implements. Here I will use implements. Vehicle. Now you can see here carefully an error is coming that it must implement the inherited abstract method from vehicle. So we'll just click add unimplemented methods and it automatically overrides the start method from vehicle. Now inside this I will print statement car starts. Now let's create another class and write a main method and create object for this car and run the program. Check on the main method and click finish. Now inside this main method I will create object for car. Now I will call the methods start, fuel type, and static method using the interface name. So this is abstract method and this is default method. And this one is static method. Now Let's run this and see the output. Now you can see the output: car starts, fuel type petrol, vehicle interface. First, C dot start. This is abstract method implemented in car. So output is car starts. Next, C dot fuel type. This is the default method. We didn't override it, so interface version runs and output will be fuel type petrol. And finally, vehicle.info. This is static method called using interface and output will be vehicle interface. So what did we learn here? Interface defines rules. Class implements and provides logic. Abstract methods must implemented. Default methods ready to use. Static method called using interface. Interface defines what we do. Class makes it happen. Now, one important point, remember earlier when we tried multiple inheritance using classes, it was not allowed and it gave error. Why does this happen? Because of ambiguity problem. When two parents have same method, Java cannot decide which one to use. So Java avoids this by not allowing multiple inheritance using classes. But here is the interesting part. Using interfaces, we can achieve multiple inheritance. Let's see how. Now I will create another interface engine. And click finish. Now inside this, I will create a abstract method. Now again I will create another interface. Music system. Now for this interface also I will create an abstract method play music. Now what I will do, here instead of vehicle I will call both engine and music system interface. Now I will implement the unimplemented methods. Now here you can see both start method from engine and play music from music system has implemented. Inside this I will print a statement playing music. Now when I run this, now let's run this and see the output. Now you can see the output, car starts coming from engine and playing music coming from music system. So here class is implementing multiple interfaces. That means we achieved multiple inheritance without any confusion. So, multiple inheritance cleanly done using interface. So, this is the code related to interface. Difference. Now let's quickly understand the difference between abstract class and interface. First, abstract class. Abstract class can have abstract methods and normal methods. It can also have variables and constructors, and we use extends keyword. Now interface. Interface mainly focus on abstraction. It defines rules a class uses implements keyword. Interface supports abstract methods, default methods, static methods, and also variables. But here is the important point. Variables in interface are by default public, static, and final. That means they are constants, not normal variables. We cannot change this value. And interface does not have constructors. One more important point, a class can extend only one abstract class, but it can implement multiple interfaces. Abstract give base, interface define rules. Common mistakes. Now let's look at some common mistakes. First mistake, trying to create object to abstract class. Abstract classes cannot be initiated directly. Next, forgetting to implement abstract methods. If a class implements interface or extends abstract classes, it must implement required methods. Another important mistake, using extend keywords instead of implements. Remember, classes extends classes, but classes implements interfaces. One more mistake, trying to modify interface variables. They are constants, so values cannot be changed. Understand the rules, code works smoothly. Homework and questions. Before ending this, I have a small task for you. First, create an interface vehicle, add method start, create car and bike classes, implement vehicle and override start method and print different messages. Next level, create two interfaces, engine with start method, music system with play music. Next level, create two interfaces, engine with start method, music system with play music method. Create class car, implement both interfaces. Call both methods. Now you will understand clearly. Now try combining concepts, use encapsulation with private variables, use abstract class for common methods, use interface for rules, apply polymorphism, and observe the behavior. This makes concepts easy to understand. Try different variations, create multiple objects, and see how output changes. You will get better understanding. Most asked questions. What is abstraction? Difference between abstract class and interface. Can we create object of abstract class? Why interface is called full abstraction? What is default method? Can interface have variables? Difference between extends and implements. Can a class implement multiple interfaces? Try this yourself. Share your answers in the comment section. If you have any doubts, ask in the comments. I will help you. Combine concepts, you will understand it better. So that's all for today. In the next video, we will learn composition and aggregation, also called has a relationship. If you found this helpful, like, share, and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to learn composition, aggregation and coupling, also called as a relationship. This is very important to understand how objects are connected and how they depend on each other in real world applications. Let's get started. So far, we learned is a relationship using inheritance. Now let's connect this to real life. Think about a car. A car has an engine. A person has a heart. A company has employees. So here, one thing is not becoming another. Instead, one thing is having another. This is has a relationship. Not is a, it's has a. What is has a? So what is has a? Has a means one object contains another object, or we can say one object is connected to another. This is also called association. It represents a real world relationship. For example, car has a engine, student has a address. So here objects are connected, not inherited. Has a means connection between objects. Types. Now let's understand the types of has a relationship. There are two types, composition and aggregation. We will go step by step. First, we will understand composition, then we will move to aggregation. Let's start. Composition. Composition, this is a strong relationship. Here, one object completely depends on another object. In simple words, child object cannot exist without parent. Example, engine cannot exist without car. If car is removed, engine also doesn't make sense. Now let's see this practically using code. We will create engine and car classes and observe how they are connected. Observe carefully, this will make the concept very clear. Now let's create another subpackage under OOP concepts. I will name this as composition. And click finish. Now I will create a new class. Which is engine. And click finish. Inside this class, I will create a method. And print a statement. Here we create a method start, which prints engine starts. Now let's create another class. I will keep this class as car and click finish. Now inside this car class, I will create an object for engine. Next, I will create another method. Now, I will call the method from the engine class. And inside this method, I will print a statement. Now Observe carefully. Inside car class, we are creating engine object directly inside the class. Then we created a method start car which calls engine.start, and then it prints car starts. Now let's create a main class and run this program. Check on this and click finish. Now I will create an object for car. And call the start car method. Now let's run this program and see the output. First, engine.starts runs and output will be engine starts. Then car prints and output is car starts. Now the important part, engine object is created inside the car. And so engine depends on car, it cannot exist independently. Because of this, car and engine are tightly coupled. This is called tight coupling. So in composition, we have strong relationship and tight coupling. That means parent object completely controls the child object. Creation, usage, everything. Let's prove this with a small change in code. What I will do, I will remove the object creation. Now what happens? There is no object creation. Engine is null. When we call engine.start method, it throws null pointer exception. So what does this mean? Car cannot work without engine. It is fully dependent. Let's run this and see. You can see the exception, null pointer exception. This is because car cannot work without engine. It is fully dependent. So since the object is not there for engine, it is giving null pointer exception. Now one more scenario, if engine class itself is removed, car will not even compile. I will comment this. And you can see error here, it is showing the compile error. So clearly car needs engine to function. Without engine, car breaks. That is why this is called strong relationship and tight coupling. If one fails, the other also fails. So this is the code part related to composition. Aggregation. Now let's move to aggregation. This is weak relationship. Here objects are connected but not fully dependent. In simple words, objects can exist independently even without each other. Example, student and address. Address can exist without student. Now let's see this using code and understand why this is a weak relationship. Observe carefully. Now let's create another subpackage under OOP concepts. I will name this as aggregation and click finish. Now here I will create a new class. I will name this as address and click finish. Now inside this class I will create a variable. Here we created a simple class address with one variable city. Now let's create a student class. Now here I will create a variable address. Now I will create a student constructor with parameter address. And again repeat. Now I will create another method. Here we are passing address object through constructor. That means student is not creating address object, it is receiving it from outside and using this dot address equal to address. We are assigning the object to the student class. This is called constructor based injection and this is what makes the relation loosely coupled. Now let's create a main class and run this. Check on the main and click finish. Now we will create object for address. Now we will create object for student. Now here I will pass address to student and I will call the show method. Here we created separate object for address and pass it to student. Now let's run this and see the output. Now you can see the output city Hyderabad because address is created outside student. So address does not depend on student. Now let's test this even without student object. I will comment this. And I have printed a statement and call address.city. Now let's run this. You can see the output Hyderabad. So here address works independently. Student may use address, but address does not depend on student. That is why this is called a weak relationship and also loose coupling. Connected but independent. So this is the code part related to aggregation. Differences. Now quick difference. Composition is strong relationship. Objects are dependent. If parent is removed, child also cannot work. Aggregation. Weak relationship. Objects are independent. Even if one is removed, the other can still work. So remember, composition, fully dependency, aggregation, independent usage. Composition binds, aggregation connects. Now one important concept, coupling. Coupling means how much one class depends on another. As we already saw, composition is tight coupling, aggregation is loose coupling. In real projects, we always try to keep loose coupling so code becomes flexible and easy to maintain. Common mistakes. Some common mistakes are creating objects inside class when not required. This leads to tight coupling. Confusing is a and has a. Using inheritance where association is needed. Not understanding dependency leading to poor design. Wrong relationship, wrong design. Best practices. Some best practices are prefer loose coupling, use aggregation when independency is needed. Use composition only when objects are strongly related. Design smart, keep it flexible. Homework and questions. Try this. Create class library and class book. Show both composition and aggregation. Also try this. Pass objects through constructor. Observe carefully how it works. You will understand clearly. Think about these questions. What is has a relationship? Difference between composition and aggregation. What is coupling? What is tight and loose coupling? When to use composition and aggregation? Try it yourself. Share your examples in the comment section. If you have any doubts, ask in comments. I will help you. So that's all for today. In the next video, we will learn cohesion, typecasting, method signature and static vs instant flow. This will help you understand code better and write cleaner programs. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to SP Learning Labs Java programming course. In today's video, we are going to learn cohesion, typecasting, method signature and static waste instance flow. First, we will understand what each concept means, why it is important. Then we will see real world examples, and finally we will implement using code. In the last video, we learned has a relationship, composition, aggregation, and coupling. Now we are moving to one step forward. First topic, cohesion. Cohesion is a very simple and important concept. It tells us how focused a class is. Let me explain in a simple way. If one class is doing too many things, your code becomes confusing, difficult to understand, and hard to maintain. But if your class is doing only one job, your code becomes clean, easy to read, and easy to manage. Let's take a real example. Imagine one person cooking, driving, handling accounts, doing everything alone. Not practical, right? Instead, one person cooks, one person drives, one person handles accounts. Work becomes smooth. One class, one responsibility. Same thing in programming. One class should handle only one responsibility. That's what we call good cohesion. Now let's see code. Now let's create another sub-package under OOP concepts. I will name this package as cohesion. And click finish. Now first let's look at a bad example. One class doing multiple unrelated things. I will create student and click finish. Now inside this class I will create methods. First, next I will create another method, print report. Next I will create another method, send email. Here observe carefully. This student class is doing calculating marks, printing report, sending email. Too many responsibilities. This is low cohesion. What I will do, I will create separate classes for this. And copy this method, paste it here. I will create another class, report printer. and click finish. Now I will copy this method and keep it here. Again I will create a new class, email service, and click finish. Now see this. Each class is doing only one job. Marks calculator calculating marks. Report printer prints report. And email service sends email. Clear separation. This is high cohesion. If we keep everything in one class like this, code becomes confusing and difficult to debug, hard to update, and even a small change can affect everything. So always remember, keep your classes focused. One class, one responsibility. That's a good cohesion. So this is the code part related to cohesion. Next topic, typecasting. Typecasting means converting one type to another. Let's understand why we need this. Sometimes the data we have and the data we need are different. So we convert from one type to another. That is typecasting. Now there are two places where we use typecasting. One with data types, two with objects in Whoop. First, let's see data types conversion. Example, int to double. This happens automatically. But double to int we must convert manually because we may lose data like decimal values. Simple idea, small to big automatic, big to small manual. Now let's take a real life example. Imagine you have a small glass of water and you pour it into a big container. No problem at all. Everything fits perfectly, nothing is lost. Now reverse the situation. You have a big container full of water and you try to pour it into a small glass. What happens? It may overflow, some water may be lost. So you need to be careful. Same concept applies in programming. When we convert smaller type to bigger type, it is safe. But when we convert bigger type to smaller type, we may lose data like decimal values or extra information. That's why some conversions happen automatically and some we must do manually with extra care. Now in Whoop, we use typecasting with inheritance. Upcasting. Child object treated as parent. This is safe. Downcasting. Parent reference converted to child needs attention. Upcasting is safe. Downcasting needs care. Now let's see code. Now let's create a subpackage under Whoop concepts. I will name this package as casting and click finish. Now let's create a new class. First we will look at data type casting. I will name this class as data type casting and click finish. I will add a main method. Now inside this main method, I will create data types. Here observe, int a equal to 10. We are storing an integer value. Now this value is assigned to double. Here Java automatically converts int to double. This conversion is called casting, specifically implicit casting. Now look at the second part. Double x equal to 10.5. We have decimal value. Now we are converting it into int. We are converting like this to int. Now here we are doing casting manually. This is called explicit casting. Now let's run this and see the output. Observe the output. Decimal part is removed, so some data is lost. So remember, whenever we convert one data type into another, that process is called casting. Now let's move to the OOP casting. Here we are not converting values, we are converting object references. This is also called casting. Let's see it. I will create a new class animal. Now inside this I will create a method void sound and print a statement animal makes sound. Next I will create another class which is a child class. And click finish. Now inside this child class, first we will extend the animal. Now inside this child class, I will create a method bark and print a statement dog barks. Now we will create another class with the main method and see the OOP casting. Now I will create object for dog. And I will refer to animal. And call a.sound. Next I will create first look at this. Animal a equal to new dog. We created dog object but storing it in animal reference. Here dog to animal, child to parent. This conversion is also called casting. This is called upcasting. and this happens automatically, so it is safe. Now look at this line, dog D equal to dog A. Here we are converting animal reference back to dog. This is called downcasting. That's why we use dog inside brackets. Now we can call dog specific method bark. Now let's run this and see the output. You can see the output, animal makes sound, dog barks. Now let's see one error scenario. Let's create another class. Which is cat, and click finish. Now what we will do, this also extends animal. Now here I will keep cat instead of dog. Now here we have created object for cat and trying to convert to dog. This is wrong casting. Let's run this and see what happens. You can see class cached exception because this is wrong casting. Even though both are animal types, but actual object is not dog. So Java will throw class cached exception at runtime. So always remember, before doing downcasting, make sure the object type is correct. For safety, we can use instance of to check the type. So understand clearly. Data type casting means converting values. OOP casting means converting object references. Both are called casting, but used in different situations and both should be used carefully. So this is the code part related to casting. Next, method signature. This is very important. Method signature includes method name, parameters. It does not include return type. Why it is important? Compiler uses it to identify methods. It helps in method overloading. Let's take a simple example. Imagine you are calling a friend, same person, but sometimes you call for study, sometimes you call for playing. The name is same but purpose and input changes. That's how methods also work. In programming, same method name but different parameters makes them different. Method signature is name and parameters. Now let's see this in code. Now let's create another subpackage under OOP concepts. I will name this as method signature. And click finish. Now inside this package, I will create a new class. I will name this as calculator. and click finish. Now we will create multiple methods, same name but different parameters, method overloading. First, void add Now, same method, I will use different data type. Now, same method, again different parameters. This time, I will add a return type. Now, observe carefully. Method name is same, add. For every method we kept add, but parameters are changing. Number is changing, type is changing, order can also change. All this together, method name, number of parameters, type of parameters, order of parameters, this is called method signature. Based on this signature, Java identifies which method to call. That is why all these methods are valid. Also notice this method, int add, and we are passing int a and double b. Return type is different, but parameters are also different. So this is valid. So remember clearly, method signature decides method uniqueness, not return type. So now let's see error scenario. Now what I will do, here we are passing the same parameters and same data types. Since it is giving error, duplicate method add. So this is invalid and it will throw the compile time error. So final point is method signature means method name plus parameters, and this is what Java uses to identify methods. So this is the code part related to method signature. Final topic, static versus instance. This is one of the most important concepts. Let's understand simply. Static belongs to class, instance belongs to object. That means static is shared across all objects. Instance is separate for each object. Why is this important? Because in real applications, some data is common for everyone and some data is unique. We need to handle both properly. Let's take a real life example. Think about a company. Company name same for all employees. This is like static. And employee name different for each person. This is like instance. Class loads first, objects come later. So remember, static, common data, instance, individual data. That's the basic idea. Now let's see this in code. Now let's create another sub package under OOP concepts. I will name this as static west instance flow. And click finish. Now inside this package I will create a class employee. And check on the main method and click finish. Now we will understand static variable, instant variable and execution flow. This is instance variable. Now this is static variable. Now I will create a constructor. And I will pass string name as parameter. Now next I will create a static block. Now inside this I will print Now I will create another method display. Now this method prints name of the person and where he works. Now inside this main method, first I will print a statement. Next, I will create object for employee and call display method. And I will pass the name. Now I will call the display method. Next, I will create another object for employee and call the display method. This is second object. Now observe carefully. Even though we change the order in code, static block is written after constructor. Still, static block runs first. And let's see this by running the code. You can see the output. First, static block executed. After that, main method started. Then, constructor executed for John, and after that, instant method executed. Same flow happens for the second object also. Constructor executed and it takes the Kohli as the name and instant method got printed. Also observe company is static, same for all employees. Name is instance, different for each employee. Now important point, static method cannot directly access instance variable. Now let's see that. Now you can see the error here. Here static method is trying to access instance variable. This is not allowed, but instance method can access both. Here you can see this company is coming from static and this name is coming from instance variable. So remember, static is class level, instance is object level. And static runs first and instance methods can access everything. So this is about the flow related to static and instance. Alright, let's quickly revise what we learned. First, cohesion. One class should focus on one responsibility. Next, typecasting. Converting one type into another, both in data types and objects. Then method signature, method name plus parameters. This is how Java identifies methods. Finally, static vs instance. Static class level, instance object level. Shared versus unique data. If you understand this, your code becomes much cleaner and easier to manage. Clear concepts, clear code. Homework and questions. Before ending this video, I have a small task for you. Try this on your own. First, create one class that does multiple things. Then break it into smaller classes and observe how clean your code becomes. Next, try typecasting. Create parent and child classes. Practice both upcasting and downcasting. Then create multiple methods with same name, change number, types and order of parameters and observe method signatures. Also try this. Create a class with static and instance variables. Print values and observe the flow. Static block, main method, object creation. Understand which executes first. Now some important questions. What is cohesion? What is upcasting and downcasting? What is method signature? What is the difference between static and instance? Clean design plus clear concept is strong developer. So that's all for today. In this video, we covered some very important concepts which will help you write better and cleaner code. In the next video, we are going to learn strings in Java, one of the most used topics in real-world applications. Almost every program uses strings, so this is going to be very important. If you found this helpful, like, share and subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome to the SP Learning Labs Java programming course. In this course, we are going to learn Java in very simple and practical way. We are not just learning code, we are learning how developers think. If you are a beginner, don't worry at all. Think of this like learning a new language. First, we learn small things, then slowly we build bigger programs. So just relax, follow along, and let's start our Java journey. What is Java? Before writing any code, let's understand one simple question. What is Java? Java is a programming language used to build websites, mobile apps, business applications. It is high-level language, which means it is easy for humans to read and write. Java was created in 1995 by James Gosling at Sun Microsystems. The first version came in 1996. Now Java is maintained by Oracle team. Now the most important concept, write once, run anywhere. Ora. This means you write code one time and it works on Windows, Linux, Mac. No changes needed. How is this possible? Because of JVM, Java Virtual Machine. JVM acts like middleware between your code and the system. It takes your Java program and runs it on any operating system. Don't worry if this sounds confusing right now. We will learn this in detail in the coming videos. For now, just remember one thing. JVM helps Java run anywhere. Evolution of Java. Java has improved a lot over time. Java Standard Edition, used for learning and basic applications. Java Enterprise Edition, used for large company applications. Today it is called Jakarta EE. Modern Java keeps getting updated regularly. Every new version is faster, more secure, powerful. That's why in real projects we usually use the latest versions of Java. Why Java is important? Why do companies still use Java? Because it is secure, reliable, platform independent, enterprise ready. That's why Java is used everywhere. Now we will run our first Java program using the command line. Let's create and execute a simple program called Hello World. You all have a notepad in your system. So I am using notepad to write the program. First we create a class. My class name is Hello World. Here we are using curly braces. These define the block of the class. The opening and closing curly braces shows where the class starts and ends. Now inside this we write the main method, which is the starting point of the program. Here also we are using curly braces. These braces define where the method starts and where the method ends. You can see here string array args. These are the arguments passed to the main method. Don't worry about this part now. Just understand that this is required to run the program. Now inside this method I will write system.out.println. Here we are using system.out.println to print the text. Whatever we write inside these codes will be printed. So this will print hello world. Here we are ending this statement with semicolon. In Java, most statements ends with semicolon. Now I save this file. The file name must be same as the class name. So I save it as hello world with .java extension. After saving the file, now we will go to the command prompt to run our first Java program. You can see here command prompt is open. Now we need to go to the directory where our file got saved. Here now I will use the Java commands. Since Java is already installed in my system, this will work. Here I am using javac. This command will compile .java files into .class files. You can see now .java file is compiled. You can check here in desktop folder. Here you can see hello world.class file is created. Now we will run our hello world program. Now when I press enter, now you can see the output hello world. Boom, you just ran your first Java program. First we compile, then we run. Don't worry if this feels confusing right now. We just saw class, main method, string args, system.out.println. We will learn everything step by step in coming videos. Java is used in many real world applications. Banking systems, e-commerce platforms, Android apps, cloud and microservices, big data tools. If the system is big and important, Java is usually there. Java vs other languages. Let's compare quickly. Java vs Python. Java is fast and scalable. Python is easy to learn. Java vs C++. Java is platform independent, C++ is more memory control. Java vs JavaScript. Java is backend systems, JavaScript is front-end UI related. Career opportunities. If you learn Java, you can become backend developer, full stack developer, Android developer, enterprise developer, cloud engineer, software architect. Java developers are always in demand. So today we learn what is JVM, what is Java, what is Aura, Java evolution, why Java is important, how Java program runs, real world usage, career options. In the next video, we will install Java step by step and set up everything properly. If you found this helpful, like, share, subscribe to SP Learning Labs. See you in the next video. Hello everyone, welcome back to the SP Learning Labs Java programming course. In today's video, we are going to install Java, set up environment variables, install Eclipse and run our first Java program. Let's get started. Now let's install Java in our system. Before that, let's check if Java is already installed. Open command prompt and type java-version. If you see a version, Java is already installed. If you see an error, Java is not installed or not configured properly. Now let's install Java. Open your browser and type download JDK. Here you can see official Oracle website. Click on this. You can see here different versions Java 26, 25, 21 and also earlier versions available now. Here you can see Java 26 is the latest release of the Java standard platform and Java 25 is the latest long-term support release and also same 21 is the previous long-term support. Java 26 is the newest version, but I am choosing 25 because it is stable and better for learning. And based on your operating system, you need to download the correct file. Since I am using Windows, I will download the Windows installer. Now you can see here 64 installer with .exe file. Now when I click on this, it will start downloading. Now you can see downloader is completed. Now I will go to the folder and click on this. Now you can see here preparing to install and you can see here welcome to the installation. We click on next. Now here you can see the where it is going to install. It will show the path. Keep those default settings and we click next. Now you can see Java is successfully installed in our system. The installation process is very simple. Now click close. Now again we go to the command prompt and type java-version. We need to close this and open again. Java-version. Now you can see the version we have installed, Java version 25. In newer Java versions, the installer sometimes set the path automatically. So Java commands like Java and Javac start working directly. But this may not happen in all systems. So to be safe, we will set environment variables manually. Now let's set environment variables. Go to search and type environment variables. Here you can see edit system environment variables. Click on that. Now here you can see system properties, edit environment variables, and click on environment variables. Here you can see fields. Now I will click on new and set a variable name as Java home. And pass the variable value as we can directly browse the directory. During the installation, we see that it is installed in C. We go to the C and go to the program files and find Java. Here you can see JDK25. Select this and click OK. Now we have given the path where Java is installed and click OK. Java home tells the system where Java is installed. And after this, now we need to update our path. Click on the path and click new and browse to the Java bin folder. Select bin folder. Path allows us to run the Java commands from anywhere. Remember, in the previous video, we ran Java commands from the desktop folder and it worked without any issue. This is because path is set correctly. Once this is done, click OK and save everything. Now, once again we type Java-version. You can see the Java version 25. Even if it worked automatically before, now we have properly configured it. So it will work correctly in any system. Now we will install Eclipse IDE in our system. Eclipse is an IDE. It helps us write, run, and manage code easily. Compared to command line, Eclipse makes our work easier and faster. Now open the browser and type download Eclipse. Here you can see official Eclipse website. Click on the first link and here you can see about Eclipse.